lo sabe? Ah, perfecto. Ok, se lo dejo acá. Y luego bueno, ya empiezo. Good morning. Welcome to this third day of conference from the Congress. I'm Lucia Rangel, and I'm glad to moderate this session. We are going to start with the conference entitled Applying Assisted Reproductive Technology and Reproductive Management to Reduce CO2 equivalent emission in dairy and beef cattle. This conference is going to be given by Dr. Pietro Baruselli. Briefly, he works at Faculty of Veterinary Medicine and Animal Science at the University of Sao Paulo. He's graduated in veterinary medicine from the Federal University of Mato Grosso do Sul, a specialist in animal reproduction for the University of Turin in Italy. He has a master and doctorate degrees in animal reproduction from the University of Sao Paulo. He's also a free technician at the University of Sao Paulo, postdoctorated at the University of Queensland in Australia, and he's a scientific researcher at the Animal Science Institute of Sao Paulo. He is also at the Department of the Agriculture. He's professor at the Department of Animal Reproduction at the the Faculty of Veterinary Medicine and Animal Science at the University of Sao Paulo since 1998. He is currently a full professor at the Department of Animal Reproduction and level 1A researcher and their programs of CNP program. Finally, he is a member of the Executive Committee of the International Congress of Animal Reproduction, ICAR. So, Doctor, it's a pleasure to have you. If you want.
¿Cómo? Gracias. Okay, good morning. It's a great pleasure to be here. First, I would like to thank the World Buiatrics Congress for the invitation. It's a great, great pleasure for me to be here with friends, colleagues, have been collaborating in this Congress in another opportunities. For me, again, it's a great, great pleasure. So thank you, Mrs. Chair, for the introduction. So what we'll talk with you about apply reproduction technology, trying to improve the efficiency of production, of course, reducing the emissions in dairy and beef cows. So the data we have, we collect in this model here. I work at São Paulo University in São Paulo, Brazil. So we have farmers that we are doing research 200 kilometers from here, but we have a collaboration with beef and dairy farmers in Brazil when you try to introduce technology. And we have also a collaboration with labs, in vitro, in vivo labs, and apply reproduction labs in Brazil. Through the last 30 years, we are doing this research in collaboration with this group. So just to introduce the importance of the cattle in the food and the nutrition of the population. So I did this analysis here using the FAO stat, just to show you that in the last years, this analysis here, FAO started in 1961, the number of cattle in the world improved from 900 million to 1.5 billion cattle in the world, but the world population increased higher than the cattle population. This is FAO data also. We are in 1961, 3 billion people in the world. Now we have 80 billion people in the world. It's a rude increment for 158%. And you can see here in cattle, we improved 62% the cattle population. Just to another important information, that around 1 billion people, according to the FAO, they have affected by hunger now in the present days in the world. And of course you know about that, but this is the United Nations data. We can see here, probably we will arrive between 90 billion or 12 billion people in the world. So we have increased here the life of the people and decreased the mortality. So we need here quantity and quality of food in the coming years, because probably we will arrive for more than 10 billion people according to this data, recently data. But the cattle here contribute about 20% of the meat and 85% of the milk production in the world. So this global demand of meat is projected to increase. So today the cattle collaborate with the meat and milk production, and the demand will increase around 50% for milk and beef for the next years. And important information that the cattle contribute for only 4 or 5% of total anthropic global methane. Because as you know, we have discordance in this data in the world, but this is several works, scientific works that support that we are collaborating around 5% of the anthropic global methane production. So this is just to introduce you the data, the scientific data, but the challenge we have is trying to using technology to have a balance between environment and food production. And cattle will contribute to have a very important role in their future in security. If you have a possibility to develop a system that can produce high food quality and with environmental sustainability. This is our challenge for the future. So we just to, again, data to understand the cattle population in the world. This is the FAA data. So in Australia, we have 24 million cattle. In Argentina, 53 million cattle. In Europe, 75 million. In United States, 93 million. In China, 113 million. In India, around 200 million. And in Brazil, 224 million cattle. So we have an important here, we need to have an important collaboration in the sustainability of cattle in the world. And just to understand the Brazilian situation, so we have the largest herds in the world. Today in Brazil, 50%, 57% of the total Brazilian area is natural forest. We have around 20% pastures for the land occupation in Brazil, and 7-8% agriculture. This is the land occupation in Brazil. So cattle in Brazil correspond around 20% of the land we have in Brazil. The cattle, the livestock have 2.6 times more land occupation than the agriculture in Brazil. During using the 20% pasture here, we can select this information and divide the cattle in calf operation and in fatting animals. So if you see this data here, this is the reproduction efficiency correspond to 70% of the pasture occupation. So it's very important to introduce biotechnology for reproduction here, trying to improve the efficiency of calf operation system, because is the most important land occupation in Brazil is the calf operation system. It's twice the total agriculture land occupation in Brazil. So if you have technology to improve this operation here, you can contribute to reduce the environmental damage of the cattle in the world. So, this is Brazil, this is the global information. You can see here then 25% of global land mass we have here is 25% grazed land cover about in the world. We have an intensive beef account only 15%. So we use in beef system in the world this grazed landing that we have in the world. So just to introduce information that is important, the methane emission beef in dairy is around 5%, and the total green grass budget we measure using the enteric methane produced by human, the carbon dioxide produced by feed, the nitrous oxide feed production manure, and the methane from manure. This is the mainly impact of the green gas in the methane productions. So we would like to now introduce you the importance of the reproductive efficiency and the application of artificial insemination. Try to measure this program, how can contribute to reducing methane emission. So this is a study we did in collaboration with Embrapa, Cargill, and USP. So trying to understand the CO2 equivalent footprint in cattle using life cycle assessment, the methodology. So what is LCA? It's a powerful tool to assessing the environmental impact of products and process through the entry life cycle of the animals. So we did this study. This study was conducted with Lais. Lais is present here. Lais, if you have some question, Lais is doing PhD with us and doing this study, trying to understand the life cycle assessment on farm and off farm. For example, for 1 kilo of milk production. So what is important here in all this information? That the most important impact of LCA is the enteric methane. It's 41%. When you use, Lais did the analysis from the several beef farms in Brazil and several dairy farms in Brazil for carbon footprint for 1 kilo of milk production, or for 1 kilo of milk production, or for 1 kilo of live weight of beef animals, you can see here in blue the impact of the enteric methane. So the enteric methane is the most important equivalent for methane sustainability. So trying to reduce the methane impact, we can increase the reproductive efficiency, or you can breeding and distributing cattle with high genetically for environmental credits. So this is the impact we think from the biotechnology of reproduction in the system, trying to reduce the carbon, the CO2 footprint. So improved reproductive efficiency is related to sustainability. So increase the weaning rate in calf weight or reduce the first calf interval, it can contribute. Remember that the calf operation system, it have a good impact in the land occupation. So this is the number in the world from calves per 100 cow per year. We have in this model here, you can see several countries in the world. Here is Brazil. Normally in South America, we have a low number of cows produced per cow. We can have high efficiency like these other countries. So this is important to have a high variability in the world in this analysis. So we can try to improve for 6 to 8% using technology, as we can see in other countries for the world. This is the age in month of first calving. Look that in Brazil we need to improve the age, decrease of course the age of first calving. Like this country here is 2 years old. Several countries is 3 or 4 years old. Of course, we have a rude here possibilities to decrease in this country here the age of first calving using biotechnology, trying to have at least 2 years old first calf. So this is using technology. We can try to do that. Why we can do this? So this is a study that we published with Lais, with Vanessa from Embrapa, Augusto Gamero is a colleague from our university also. And what we're trying to introduce in this model, the effect of reduce the age of first calving and increase the weaning rate, trying to understand the impact of this on the CO2 production. So here is two systems. One system produces 400 male with low reproductive efficiency, so 6% weaning rate or 48-month age of first calving, or high efficient, 8% weaning rate or 24 months first calving. What's happened using this model here, the land occupation is reduced, the tons of CO2 per year is reduced, and you can here increase the efficiency of the system in around 40%. So improving the reproductive efficiency, we can reduce 40% the CO2 equivalence emission per kilo of calf produced. This is the model just to show you the impact. So this is a study that showed that the amount of CO2 per 450 kilos of live weight, this is the unit that we use in our model. So all this here was a study. So one unit of animal can produce per year 1,500 kilos of CO2. And using this model here, for using 450 kilos as a unit, so when we have a calf that calving 4 years, this calf here is related to the production of 6,800 kilos of CO2 equivalent. If you decrease the age of first conception, first calving, look, this calf here was produced using a low amount of CO2 equivalent using these models. And if you reduce again, we can produce a cow with low amount of CO2 equivalent. So all this information here is important to show you the equivalence of age of first conception, first calving, the CO2 equivalent model, okay? So we have a strong reduction. This is the Virginia Tech study that a group of research produced a very important information. When they use they increase the live calves born per cow per year, they can reduce the land use, reduce the water use, and reduce the carbon footprint using the reproductive efficiency of the cow. This is a study did also in the United States, showing the importance of increase the reproductive efficiency and reducing the environmental impact of the system. So this analysis we did in Brazil. So if you have cows that produced 50% weaning rate, one calf will be producing 3.2 tons of CO2 per year. But if you increase the weaning rate, the same cows we can produce with 1.7 tons of CO2 equivalent. So this is just show you importance of the reproduction. But how we can increase the reproduction, mainly in the tropics, when we have more pastures on our land occupation. So what's happening in the tropics? What's happening? Normally, after the calving, you have a long estrus, and the first ovulation is delayed, so we have a low reproductive efficiency in this model here. So we did several studies, and other groups did several studies. So in the tropics, normally 8% of the cow are in an estrus when they need to become pregnant to have 12-month intercal interval. So what we are doing, using biotechnology for reproduction, this animal here, when they are cycling, they produce estradiol and progesterone. So we treated the animals, we supplement the animals with progesterone and estradiol, and we induce an early ovulation here in these animals. These animals can be used here by artificial insemination, and the non-pregnant animals, we induce cyclicity. So this model here is an efficient model to increase the inducing cyclicity, increase the reproductive efficiency, try to produce more calf per year, and this system will collaborate with the sustainability. This is a study we published 20 years ago in collaboration with Gabriel Bo. But normally in the tropics, we have a high incidence of postpartum estrus, low efficiency of estrus detection, and this biotechnology of reproduction here, the fixed time AI, could be an important technology to increase the reproductive efficiency of the system. Not only reproductive efficiency, but also can improve the genetically of the animals, trying using the best bulls through artificial insemination. This, just to show you some study we published, this is a study comparing natural cervix. In the world today, 8% of the cows are produced by natural cervix, but we can introduce here fixed time AI. And when we introduce fixed time AI, this is a model that a study we did in 500 animals, same group, same bulls, no variation. Look that when we use fixed time AI, we decrease the interval to establish the pregnancy, and we increase also the pregnancy at the end of the breeding season. So this is very, very important information to increase the reproductive efficiency of the beef system in the world. And in dairy is the same. When you use dairy, we can use a rude program using fixed time AI in the early postpartum, trying to detect the animals, the non-pregnant animals by ultrasound, and do several fixed time AI. If we use this model here, we improve the pregnancy rate. So the normal pregnancy rate in the tropics is not so high, 50% pregnancy rate in 21 days. But using biotechnology, we can, just an example, trying to increase 15 to 23%. So what's happened? We increase the days in milk of all the farms, increase the daily milk of the farms. The mean of healthy milk production will increase, only increasing the reproductive efficiency. Though this is very important information. This is one data from José Santos group, from Eduardo Ribeiro. It's very important information. So when we decrease, reducing the calve interval from 60 days, we can increase 1.5 liters per day, or 500 kilos of milk per year. So the reproductive efficiency is very important also in the dairy system, trying to improve the milk production with the same number of animals. With the same number of cows, we can increase the milk production if we increase the reproductive efficiency of the model. And this is another study that Laís published. We published the last year. So the influence of calve interval in carbon footprint in lactating cows. Look, if you increase the number of, reducing the calve interval, of course, on the time, we can improve the milk production and reducing 30% the carbon footprint also in milk production system. And trying just to show you how we are using biotechnology of reproduction to reduce the age at puberty and the first conception. So normally in the pasture conditions, the puberty is achieved 2, 3, 4 years old. So this is no efficiency model. What we are doing, we are using also the induction of ovulation, trying to induce puberty, precocious puberty in the cow. So we using treatments for synchronization, primes of the same hormones that they produce, so we can anticipate the first ovulation, we can anticipate the first corpus luteum formation, we can introduce the fixed time AI early in the age, and in this model here, prepare the uterus from the heifers to become pregnant. So today we have a technology in the tropics to introduce the first conception rate in calves in 1-year-olds, and this we have a strong impact in the system. So, of course, this is not easy. We need to control the nutrition and the genetic of the animals and improve it. But all this is published. We can see the reviews, these reviews again we published with Gabriel, trying to understand the artificial insemination versus natural service in terms of efficiency, in terms of the economic return. So today we have a technology to introduce in the farms to have a high reproductive efficiency. The farmers can take more money using AI, and we have more sustainability, reducing the CO2 emissions using biotechnology in this model. So all this here is important. But this, again, strong information is important information from groups of research that when we have here the animals that have less productivity are more inefficient. This is the problem for CO2 per kilo products. So we need to introduce technology, improving the reproductive efficiency, trying to change our model from an inefficient model for an efficient model. If you are doing that, like improving the reproductive efficiency, introducing technology, you can reduce the CO2 equivalent per product for kilo of meat or kilo of milk production in the system. So, fixed time AI, improve the reproductive efficiency and multiply future generation of cattle characterized by better efficiency, improving the productivity of animals, and of course, collaborating for a reduction of CO2 equivalent. So, another important biotechnology to mitigate the methane emission is the embryo transfer. So the embryo transfer, this is the data for ITS. This is the number of embryos we are producing in the world. Look that we are increasing the embryo production in cattle in the world in the last year. And you can see here also in 2006, in the world, we changed the model of embryo production for in vivo, that is here, and we are producing more in vitro embryos that is more efficient in the world cattle embryo production system. This is just to understand the importance of the number of embryos are increasing, and this is important from the productivity of the cattle system. So, but the embryo transfer can collaborate with genetic improvement, of course, but also with reproductive efficiency. This I will show you. Of course, if we take, here's some characteristics from genetic production. If you can take the best donor and the best semen, of course, introducing recipients, we can collaborate with genetically improvement. So we can utilize this for production or for selecting animals that produce with low CO2 equivalent. So increase the rate of dissemination of an animal with high characteristics for genetic medicine. And today you have a genomic SNPs that we can utilize to produce in cattle to have attribute efficient fertility and also reduce enteric methane production. So this is, as you know, in the literature, we can select the animals for reducing enteric CO2 in accordance with improve the efficiency of the production. So this is just to introduce the importance of embryo transfer, but it's not only in genetically improved, but also in reproductive efficiency. So this is the one study we did using our embryo transfer to improve reproductive efficiency. So the embryo transfer, like in heat stress animal, can, of course, increase because the heat stress animal have a low oocyte quality, and the embryo transfer can be introduced in this model here, trying to improve the reproductive efficiency, mainly in the tropics, in animals that have low heat stress during some time of the year. Like this data here, we published with Carlos 20 years ago. This is 700 AI and 2,000 embryos transferred. Look here, here is the heat stress time. When we use AI, we have this conception. When we introduce embryo transfer, we increase the conception rate in animals during the heat stress. So this is important. So just to show you that we can introduce here genetically, and we can also improve the reproductive efficiency using embryo transfer like in heat stress animal, or in repeat breed cows and heifers. So what we can do in repeat breed cows? In repeat breed cows, we have a lot of AI and low reproductive efficiency. So the incidence in the world is between 9 to 24% of the cattle in the herds they are repeat breeds. So we can use here embryo transfer after several AI, try to improve the efficiency of repeat breeder cows. This is another study we did with Carlos. This is the conception rate from AI, decrease 77% when we use AI in repeat breed cows, but when we use embryo transfer, the conception rate was the same in non-repeat breed than in repeat breed. And also the pregnancy loss is the same in repeat breed and non-repeat breed cows when we use embryo transfer. So the embryo transfer could improve the efficiency of AI in repeat breed cows, trying to improve the reproductive efficiency. So this is the data we have here, trying to show you the importance of the repeat breed. And just to show you also, we did a study from our PhD student, Roberta, trying to understand what's happening during the heat stress. So we have a low oocyte quality, but the uterus is good to receive embryos and to receive to increase the conception rate. Trying to understand, we did a model. This is a model reducing the service rate from embryo transfer, but increase the conception rate. Of course, we reduce the service because we transfer embryo only in animals with corpus luteum, but also using embryo transfer in repeat breed cows or in heat stress animal, we can improve the reproductive efficiency in 53%. So this is the importance of the embryo transfer for the importance of the embryo transfer for the reproductive efficiency. But as you know, we can produce the embryo, but we need to transfer the embryos using biotechnology of reproduction. So what we did, we tried to improve the transfer treat rate. This is a big problem for inefficient recipient model. So we have a low embryo treated rate in a model. So for transferring 100 embryo, we need 300 recipients. But if you increase the transfer to treat rate, we decrease the amount of recipient we need. Of course, as this recipient produce CO2, of course, for transfer 100 embryo, we need a model that will have a high transfer treat rate to decrease the carbon footprint. This is the data we published more than 20 years ago, showing that we can today using fixed time embryo transfer. We did this experiment in collaboration with Gabriel. And look here, we can improve the pregnancy rate using fixed time embryo transfer in beef and in dairy also. We can have the dope of cow pregnant using fixed time embryo transfer. So this is very important to the efficiency of our system. So trying to finish in our presentation, this is another important information for improve the efficiency of our model is decreasing the generation interval. Decreasing the generation interval, we can improve the reproduction, and of course, trying to multiply efficient animal that produce low CO2 emission. So this is just a review we published in the last years, trying to understand the quality of oocyte and embryo production in different ages or stages, in calves, oocyte according to the age. So we are trying to produce embryos with genetically young animals and reduce the intercalve generation. Of course, we have a cow, and the donor is not the mother. The best cows from genetically is the calf, not the donor. So what we try to do in this model here, using young animals as a model for donors for improved genetically situation. As you know, if you decrease in the generation interval, we increase, of course, the genetic gain in our model for impact, for introduce some characteristics we would like to introduce, introduce animals that produce lower CO2 equivalent in the situation. This we can name it velogenesis. Is not young, so this we have researchers that started with this model years ago. So just to understand the impact of this technology, here you can see here, if you have adult donors or if you have a calf donors, we can impact genetically milk production, like genetic milk production, using this donor here, calf donors. In 10 years, we can reduce in 10 years the same genetic improvement, because here the intercalve interval is 3 years, the interval between generations 3 years. Here is the interval between generations 1 year. We can accelerate strong. This just to show you this microdocument data. So this is a calf, 3 months old, using FSH. Look here, more than 100 follicles. This is the potential for an embryo production. This is the data we did in São Paulo University with Julio, using, this is the Nelore cows, this is the ovary, we use FSH, and we produce the embryos using laparoscopy. So in Nelore calves, in Holstein calves, this is our student in our lab doing the embryo production. This is the data we published years ago. When you take a calves, you can have here, an Nelore calves, 32 follicles or 32 follicles. You can produce 2 embryos per calves. This is 2 months calves, just to show. Here is a Holstein. We can have 50 follicles in one Holstein. Just show the potential we have to produce embryos. And this in Brazil is the first calf born. This is 2015 in our lab. This calf is here. The mother had when we produced the embryo, they had 2 months old. So, of course, the conception rate is lower in calves than in cycling animals, of course, but showing that you can do that. In Holstein, the same. We produced these calves. The mother was 2 years old. Now we are using this model to produce embryo for young animals, using a probe with a little to introduce in the vagina of the calves. This is the calves we are producing embryos today. So the jury also, this calves here, the mother was 3 to 7 months using this technology here to embryo production. Of course, the conception rate of the embryo of calves, we transfer the same day at the same moment, is lower than cow. we need to increase the embryo transfer system, but we have technology today to produce 40% or 30% 6-day conception rate in an embryo for a calves. So just to show you that's possible. And we have a marker, also AMH marker. This AMH marker, we can select donors using AMH. We can select adult donors. This is adult donors, cow. Using this model here, we can produce more embryos using AMH, higher AMH, more embryo production in zebu, higher AMH, more embryo production in Holstein. We have a strong correlation, so it's a biomarker for cows, but also for calves. We published this data here using AMH in calves. Look at the calves, we measure the AMH, more embryo production in calves, in Holstein, in more AMH, more embryo production in calves, in calves zebu. So AMH is a marker for fertility. Just to remember that calves have a higher AMH than cow. This is normal. Calves have more follicles, so they have more AMH than cow, both in Taurus than in Indicus. And AMH is a marker for number of follicles, but it's not a marker for fertility. Look, high AMH in the donors, no improvement in the conception rate. So just to finalize, AMH is a marker for follicle population and number of embryo production, but not for quality or fertility, just to show you as we use it. And we are using also FSH in young animals, in prepubertal animals. We did this protocol here. We using FSH, improving the number of 1.3 for 3.5. Using FSH, we increase the number of large follicles in prepubertal Holstein heifers, and we also use today the conventional FSH and the recombinant FSH. Look, when you use recombinant FSH, we can improve also the size of the follicle, become more large follicle. Look here, control group is no large follicle. This is the animal using FSH. Look here, we improve the size of the follicle, and we know that here we are improving the quality of the oocyte, improve the efficiency of the system. So we improve using FSH the system, and we improve also the number of blastocysts per OPU using FSH. So this is trying to increase the efficiency of the system. So here, just to detect it, so we have here finishing the urgence for moving the next generation. So we increase the prepubertal animal and we reduce the intercalve interval, improving the system. So the balance, we can also be afraid, because when we use animal that is more efficient for residual feed intake, we can also reduce the CO2 equivalent, but we reduce the fat in the heifers, and we reduce the conception rate. So this is the balance we need today. So if you have animal with more efficient conversion, they produce lower CO2, but they reduce the conception rate. So today, in the marketing, we have a system that we can select animal to have a high efficiency, and we can today use this animal to reduce the CO2 equivalent. And we can improve 9 to 95% CO2 emission using genetic. So genetic is very important for the system. So this balance here between feed efficiency and reproductive efficiency is a challenge for us in the future. We cannot use a lot of feed efficiency selection. We can reduce the reproductive efficiency. So this is the balance. So finishing, the poverty need to be reduced. The challenge is produce food. but we in collaboration between research and industry, but trying to reduce the impact of the beef and dairy and beef system in the security. In selecting breeding ruminant with natural methane, this is genetic selection. As you show you, we have today DNA markers for select the animals that have low methane production. The breeding programs selecting lower methane emissions, and the reproduction biotechnology can accelerate the genetically trying to introduce in the next generation animal that is more efficient for the system. So AI and embryo transfer can collaborate, of course, for beef and dairy, trying to improve the efficiency of the system. And finishing, we would like again to thank the organizers, to invite me, the Carryover, for support my travel to be here, and all my PhD students, and the collaboration of a lot of labs, international and national labs, and the foundation that help us to develop the research that I show you. So thank you very much. If you have some questions, I will be here with you. Thank you.
Thank you. No tenemos más tiempo, pero sí, no hay problema. Muchas gracias, doctor. Gracias. Okay. Well, we are going to continue with our program. Is here Dr. Zdzisław Gajewsk. Okay, thank you, doctor. The next talk is entitled The Influence of the Uterine Activity in the Cows During Postpartum Period, and is going to be given by Dr. Zdzisław Gajewsk from Poland. Thank you, doctor.
Yes. Good morning, everybody. I will speak about the influence of the uterine activity in the cows during postpartum period. The endocrinology of the postpartum period was relatively good described or explained by the first speaker, and we know that very important it is the endocrinology from the postpartum till we start to the reproductive season. The various physiological changes occur in the reproductive tract, including the uterus. The uterine contractility play a really crucial role in the fetal membrane's explosion during the involution of the uterus and prevention of many postpartum complication disorders. We know that several factors can influence the uterine contractility. They are hormones, they are ions, that is very important sympathetic nervous systems, especially adrenergic systems. To understand and monitoring the uterine activity in the physiological and pathological status are essential managing the reproductive health in the cattle. The technique which we can use to measure the uterine activity, that is ultrasonography, electromyography, and hormonal assays. Proper nutrition, hygiene, and veterinary care are are crucial for maintaining optimal uterine health cattle. The most important risk factors for cattle, uterine disease, which measures can help prevent them. The risk factors, for example, uterine damage, and the preventive measures, optimal environmental and assistance around calving. The metabolic disorders, the diet meets the cows changing the needs. The uterine bacterial flora as a risk factors, and the preventive measures, prophylactic treatment with probiotics. Immunosuppressed status, close monitoring and quick response to symptoms. The involution pattern of cervix uterus in postpartum Holstein dairy cows. It is as an example, and we can observe that the cervix uteri diameters gradually declined in different parties. Depends, it was primiparous or biparous or multiparous, it is more or less the same. And the involution of the pattern of the pregnant uterine horn in postpartum cows, the gravid uterine horn diameters of biparous and multiparous decrease faster than those of primiparous cows. The average involution period of cervix, uterine horns in different ages. And the results shows that the cervix involution period was significantly higher for the 2H cows than in the older cows. The same was with the gravid uterine horn and non-gravid uterine horn. To better understand the physiology and the pathology of involution during postpartum period, we have to remember the typical tubular structure of the reproductive tract, and especially important for us are the circular and the longitudinal smooth muscles layer. More complicated is the preparing for the contraction and the anatomy and histology of the smooth muscles presented on this slide. And now, the end of this process, it is the relaxation or contraction of the smooth muscles. The objective of the study was to control and determine uterine motility and the measuring of the influence of different drugs on the uterus measured with electromyography system and ultrasound methods during the postpartum time in the cattle. In the experiment was used the Holstein Friesian cows for 7 years old and 800 kilogram body weight. The electrical activity was recorded with the 6-channel pen recorder of sensitivity 1 centimeter connected to the biological amplifier as described earlier. The frequency band 2 to 100 Hertz. For the analysis, we use the duration of electrical activity paired, myoelectrical index being the sum of duration of the beats recorded during a session in T seconds, and the number of the beats in the 10 minutes period. The transrectal ultrasonography was used to quantitate uterine contractile activity during postpartum period with the use of ultrasound. The probe was 5 megahertz. The effect of the oxytocin of the uterine electromyography activity, and we can observe that after the application, the amplitude and the duration of the beats was longer in compared to the time before. The use of the prostaglandin dinolytic on the uterine EMG activity showed us, after the application, the really high increasing in amplitude, duration, and the time of the beats after the application. The carbotocin effect on the uterine EMG activity showed us increase of the amplitude and the time of the duration of the electrical activity. The application of alpha-2 stimulator detomidinum hydrochloricum showed us the increase in amplitude and the short increase in the number of the beats and the time of the duration of the electrical activity. We used the other product. It was ergotin, and the ergotin showed us the small effect, not so high like with the using of prostaglandin or oxytocin, but we could observe the positive influence on the electrical activity. The myoelectrical index during the first 4 weeks show us, like the previous slides, the decreasing of the length and of the diameter of the uterus. The same was with the activity, electrical activity. During the first weeks, it was very high in all places where were located the electrodes. The second, third, and the fourth weeks, it was less and less in compared to the first week. But it shows that the uterus contraction decrease and the uterus will be prepared for the next reproductive season. The same results with the mean duration of the beats. During the first week, the beats was with the high amplitude, and the time of the beats was relatively longer in compared to the next weeks postpartum. And the transrectal ultrasonography, contractile activity during postpartum period, we observed the main changes in the uterine contractility score in the postpartum cows, and during the first days postpartum, we could observe much higher much higher score. It was more than 3.4. The highest was 5, but we didn't receive it. And about the 42 days we observed against the high. It was compared with the pro-estrus and estrus phase. In the results, we can see that the application of oxytocin showed significant increase in EMG activity in the amplitude, frequency, and duration of the births. The same results was observed after the application of prostaglandins, which was characterized by the increase of duration of the myometrium activity, both uterine horns and the corpus uteri. The application of carbotocin increased the uterine motility in amplitude and frequency of the EMG uterine activity. Transrectal ultrasonography used to quantitate uterine contractile activity during the postpartum period. The ultrasound measuring showed the decreasing of the uterus horn diameter and the length of the uterus. In the conclusion, we suggest that the evaluation of morphological changes occurring in the uterus is an interesting application of diagnostic ultrasound. The ultrasound characterization of the uterus shows differences depending on the phase of the postpartum period. The uterine contractility is an important mechanism involved in the uterine evolution, which determines the retraction of the uterus and the clearing of the uterine lumen of fluid and the tissue. Disorders of the uterine contractility predispose the cow to many diseases of the postpartum period. Proper treatment of uterine contractile disorders allows the cows to return the production cycle more quickly. The presented telemetry system has a great advantage methods as well, since it can be applicable in the freely moving animals. Moreover, it's accurate to determine the electromyography signals features. That is our facility part with the animal part and the human part and the translational laboratory. We are from the Center for Translational Medicine, Warsaw University of Life Sciences, that is Poland in Middle Europe and Warsaw. I would like to say thank you for all collaborators which were described on the first slides. Thank you very much for your attention.
We don't have time for questions, sorry. We don't have time for questions, but I'm sure that doctor is glad to ask you directly. Sorry. Well, continuing with our program, the next conference is entitled Pregnancy-Associated Glycoprotein Carryover in Individual Milking Robots. It's going to be by Dr. Rafael Paiva from the USA. Thank you, doctor. ¿Le van a poner ahí el reloj? There's going to be the time there.
Okay.
Do you know how it use? Es para avanzar, para regresar y para... Gracias.
Thank you very much for the organizer of the Congress to allow me to share this experience with you. My name is Rafael Paiva. I'm from Venezuela, and I'm doing a PhD in Texas A&M University, and I also work for IDEX as a professional service veterinarian. We're going to talk today about pregnancy-associated glycoproteins in carryover in individual milking robots. This research started because I went to this dairy. They were just starting with the robots, and they were collecting samples manually to send those samples to a lab. And I know that this brand of robots have a device that can collect the samples automatically. So we did this study to see if they could use the word carryover in the robot between samples. So robots are not new. They have been in the US and Europe since 1999. And I talked to somebody in this Congress, and that person told me that also perhaps earlier, since 1991. This brand, Lilly, they first invented the robot more than 17 years ago, and they have installed above 9,000 robots globally. The main driver for producers to change to robots is because they free them of time, especially in not very big farms. Farms with about 1,000 milking cows are considered small in the US, and it frees time to the producers and workers to do other activities. What is carryover? So carryover is a contamination from one sample, in this case milk sample, to the other when you collect them in a milking system. If you have about 3%, a study says about 3% carryover for components for protein and fat and somatic cell count is not very important. It's not a big percentage, but if you're going to do pregnancy, like we did in this study, or if you're going to do diseases, 3% is a lot of error. So we try to see, that's the point of this study, to see what was that carryover. What is sample-based pregnancy test, as we call it? It's a method that you can collect blood or milk. In this case, we use milk at day 28 post-service and during all gestation to detect the open cow. I always say that they call it pregnancy test. They should have called it the open cow test. You don't need to log the cows. The cows doesn't even know that they have been sampled and tested, and there's no extra time, no involvement of any kind of labor for this. What do the farmers of robotic dairies need? They need an early pregnancy check or early open detection of the open cow, reduce log time, increase free movement, increase the lay down time, and also all of these comes together to animal welfare. And in this type of milking parlor of these robots, the risk of carryover is higher than in a conventional milking parlor. So packs are produced around day 22 of gestation. They move to the bloodstream of the cow around day 23, 24, and most of the available kits, commercial kits, are above day 28 or day 28 and above, because there's where the sensitivity and specificity is the best. These packs are producing the trophoblast giant cells in the placenta. They're produced by the fetus, by the embryo. That's very important. They're not produced by the cows. Okay? And these are specific markers for pregnancy. If you compare with progesterone, progesterone is a marker for pregnancy, but it's not specific because, as we know, the cows can produce progesterone even when they're not pregnant. Cows cannot produce packs if they're not pregnant. No embryo, no placenta, no packs. Okay, this is a picture. I just want to point here that we did in our lab in collaboration with Dr. Johnson's lab in Texas A&M University. And you see in the picture of the left, and I just want to point here, this is a day 21 pregnancy, this is a day 31 pregnancy. Everything that is green here are packs. Packs were colored in green. This is the endometrium, This is a trophoblast, and you see there's a little bit of green here, a little bit of packs, but 10 days later, there's a lot of packs. And here's when those trophoblast giant cells start to migrate through the uterus, through the endometrium, and then they go to the bloodstream of the cow. That's how we can detect those packs in the bloodstream of the cow. So in sample-based pregnancy tests, one advantage is that the results does not depend on the examiner, on the ultrasound, as the ultrasound does. At day 28, several studies show that the accuracy of the test is higher than ultrasound or hand palpation, of course. And there was another carryover study did in this same robot, but with a different device. It's called the Lely Orecollector device. The one that we're using right now is called the Astronaut. And they found in this study a sensitivity of 100% and a specificity of 96.2%. But what they did is that they increased the milk pump time from 5 to 9 seconds. And I'm going to show you some what we did in our research. So the objective was to determine if there was any carryover or the level of carryover in milk using this Lely sample for the astronaut robot. The dairy is located in northwest Texas. They milk about 720 cows with 12 robots in a forced ventilated barn, 3 robots in each pen, 2 in a tandem, and 1 satellite robot. That this satellite robot allows the producer to sort the cows and move them into a management pen. I'm going to show you a diagram and some pictures. And they collected the samples by hand every 2 weeks in those eligible cows between day 28 and 42 after AI. The cows were locked in this management pen. They collect the samples, and then the same day when we started the study, those cows will exit that management pen through the satellite robot, and that's where the sample was collected. So we had 2 samples from the same cows, about 1 hour of difference, one collected by hand, one collected by the robot. So this is a diagram of the pen. So they have the pen, about 240 cows in each pen. They have these 2 satellite robots. The cows can come in when they want. And then they have this satellite robot. If the cows come in here and they tell the computer to sort the cows, when those cows exit, they stay in this management pen, and there they do AI, supply hormones, drugs, whatever they need to do in each cow. And here is when they collected the sample for the pregnancy test. This is the robot, and this is the device that collects the samples. It can collect up to 90 samples at a time, and it's connected to the robot, managed by the vacuum system, and it has a milk line that moves the milk from the milk bottle to the collector. This is a picture of the forced ventilated barn. There are 3 pens like this you see here. There's there's 4, 2 more to the right. And these are the 2 satellite robots, and the 2 tandem robots, and this is the satellite robot with the management pen where they lock the cows and as needed. This is how they collected the samples. The herd manager came and by hand milled the cows, and you could say that there's no risk in a Holstein cow to collect a sample like this, but sometimes the risk doesn't come from the cow you're working, it comes from the cow on the side. Let's see if the video works. You see there's a big risk of having something happening collecting a sample. So not always the cow that you're working is the most important. So this is the sampler again. In this milking bottle is where the milk comes out from this hose and goes into the collector. And you're going to see a short video here how the milk goes into this recipient, and then this recipient, and then it goes through this small hose to each tube, and then with vacuum, the device moves that carousel with this arm up here to move to the next sample. What I saw is that the place where you could have some carryover is in this reservoir, where it could be, you see a little bit of milk in the bottom. So the results, I'm pretty good on time. I did a ROC curve for those samples using the manual collected samples as a gold standard, and we saw an area under the curve of 0.933, which is very good, with a statistical difference. And we found sensitivity and specificity, positive predictive value and negative predictive value of 98%, 0.98, so 2% of error, which is close to what the manufacturer calls for sensitivity and specificity. I ran a Spearman's coefficient of correlation and a correlation of 0.786% or 78%, which is a very strong correlation in between the samples collected by hand and the samples collected by the robot. Also, I wanted to show this table. If you see here where it says robot number, this is the robot number and the sample, the number of the sample collected that day. So on this day, this is sample number 1 collected by robot 7, sample number 2, sample number 3. And you see that this was a pregnant cow and the 2 following cows were open. So we didn't have a carryover in that case. Same happened with this 7006, 7007. First cow came pregnant, the other one was open. The 7011 and 12, the same. And then robot 12, sample 3 and 4, the same. A pregnant cow came in first, and then an open cow came, and there was no false positives because of the carryover. So, as conclusions, the samples collected by the robot sampler will have the same performance than those one collected by hand. Sensitivity, specificity, negative predictive value, and positive predictive value were 98%, only a 2% of false positives and false negatives. There's a strong positive correlation of 0.786 between the milk samples collected by hand and by the robot sample, with a 95% coefficient of interval. This brand of robot can be used with strong confidence on results on open cows, or not the robot itself, the robot sampler. In robot dairies with this system, they can use this sampler with confidence for pregnancy determination, and this will allow to do a non-invasive pregnancy check at the early stage of gestation with less stress, better comfort, and animal welfare based on other research. And based in that research, we have previews. If we can, they can increase the herd milk production, but also if we increase by 6 seconds the milk pump, we could reduce this carryover from 2% to below 0.5%. As a recommendation, of course, we need to do more research in different brands. There are about 6 or 7 different brands of robots worldwide. And this same research or this same carryover study should be done in every brand of robot to know if there's carryover, because the systems are completely different. I want to thank you, Dr. Kai Poller's lab. This is a picture of my colleagues from the lab. Sorry. Wolf Legendary, where we did the research. Lely for all the support. Trying to connect these devices was not easy, and make them work properly was also a challenge. And IDEX that provided the kits to run the test. Thank you, and you have any questions?
Okay, thank you. Thank you. We have time for questions, if everyone has a question.
Something I want to mention also about this is that in this dairy, and because of this study, 3 or 4 different dairies started to use the collection system. The idea is not to replace the veterinarian by the pregnancy test. The idea is that the veterinarian focus on the open cows and come to the dairy to do a gynecological exam of the open cow to tell them what is going on wrong with that cow, and then get that cow pregnant, or make a decision if the cow is going to be cooled, do not breed, or what is going to happen with that cow.
Okay. Is there any question for the doctor? No? You say this is available for commercial, the robot is available?
Yeah, the robots are available, and different brands of robot has been installing in the US and Europe. In a big scale. There are dairies with 50 robots, 25 robots, because producers, there's a lack of workforce in these countries, or workers are very expensive. So with these robots, they can replace a lot of workers and reduce the labor and the problem with handling labor. So in this dairy with those 12 robots, they have only 3 workers. Those 3 workers go through the pens, and one of them is in charge of the robots, checking that everything is working properly in every robot, cleaning them and doing some inspections, and the other 2 are just checking the cows. They can go to the robot and check which cow has not been milked, and they can push them to come to the robots. So it's a technology that is helping some producers. I don't think it's for everyone, but it helps some type of producers.
Yes, it's very interesting. Well, if we don't have another question, we ask. Thank you, Doctor. Well, the next talk is entitled Pregnancy Evaluation with a Point of Care Pregnancy Test in Dairy Cattle. It will be by Dr. Zoltán Szelényi from Hungary. Thank you, Doctor. Okay, please talk closer to this, or if you want, you can do that. This is forward, reverse.
Okay,
and
this is
mark.
the laser.
Okay, thank you.
Thank you very much. My name is Zoltán Szelényi. I'm coming from Hungary. I would like to thank for the scientific committee for accepting my paper for speech, and I will be really strongly linked to the previous lecture. I will talk about pregnancy evaluation, namely the pregnancy test with a so-called novel point-of-care pregnancy test. I'm coming from the European Union, from the central part of it, and I brought some statistics from the official website of the European Union. This is saying that the situation by us is that the number of every farm animal, including cattle, is declining in the last years until when, until when the milk production has increased in the last 5 or 8 years with around 15%. That's happening through the This process is happening that in general we have large, especially in the eastern part of Europe, we have large herd number in cattle farms. For example, in my country, the number of animals per herd is the largest in the European Union, which is somewhere around 450. And in the recent years, we started to have cows with more than 2,000 cows in the country. We have altogether 200 cows. Most of these are dairy, and around 400 farms. And each farm started to increase the number of cows, so they started to concentrate production. Meanwhile, the so-called backyard farms, I'm calling backyard farms with low number of animals, up to 30, in my country they are not decreasing in number, then they are disappearing or diminishing from the system. So milk production is really focusing onto large farms by us. I don't want to, we have heard about the pregnancy proteins. Just a few words that I would like to add to the colleague's speech. Originally, at the when these proteins were purified, there were 2 kinds of proteins, the pregnancy-associated glycoprotein and the pregnancy-specific proteins, namely A and B. The specific proteins coming from Idaho, they were commercially available since now 30 years. Regarding to the pregnancy-associated glycoproteins, initially they were mostly available for research. Nowadays, from the so-called Cetartiodactyla genus, they are sequenating more and more proteins. Namely, in bovine now there are 22 proteins are sequenated, while in other species less. even though we have that huge number of proteins and decades of research in the process, we still don't know what is the function of these proteins. In humans, they are using it for, used earlier as a gold standard for fetal well-being measurement from maternal blood, while in animals, we are just using out the probability for pregnancy testing. The clinical application has two disadvantages. The clinical application for pregnancy testing these proteins has two disadvantages. First of all, that the half-life of these proteins in the maternal sera is a few days. That means that at the moment when we are taking a sample, that can come from a non-viable embryo as well. A few days are lasting until the decline of the protein concentration starts. Secondly, before calving, there is a 1,000-fold peak in the concentration of proteins, meaning that it needs to have half-life as well. And all the samples which are taken in the first 80, 90 days of in milk of a cow for pregnancy testing, that's not much samples, but there are a few samples, can be contributed because of the previous pregnancy persisting proteins. The testing of these proteins was revolutionized when IDEX came out in 2010 for a milk test for pregnancy-associated glycoproteins and made it commercially available. And since then, the certain test has been renewed twice. In 2006, there were a sandwich ELISA came out, which was applicable for on-farm, for visual readout. And in 2023, a novel lateral diffusion test was applied. All these tests, which are measuring from the different biological fluids, the pregnancy proteins, are carrying the problem that the filtration through the blood-milk barrier or the blood-urine barrier is decreasing the concentration of the proteins in the biological fluids. Therefore, they are not always accurately applicable for pregnancy testing. But as the previous colleague said, soonly they will be built into robots, and that's the future where we are heading for. After this, we talk about the veterinarians' work in the system, in the pregnancy testing system. Recently, there is some literature about that. If we assume that one cow requires, just for pregnancy testing, 1 to 4 transrectal ultrasonographic or transrectal palpation examinations per year, the increasing concentration of cattle farms puts increasing efforts onto veterinarians, namely the hazards that are coming from the profession are either mental burning out or physiological burden that we all face here in the room. And there is physical challenge as well. For equine practitioners, since 20 years we are having literature about the increased incidence of fracture of the long bones due to the profession. And as I put up some literature recently, cattle practitioners, it can be found in the literature that cattle practitioners are suffering from physical issues or physical challenges, which are mostly affecting the upper limbs, and more literature is coming out in this topic. After this introduction, let's see our study. We took 637 animals, and the study was carried out in 2022. In spring and autumn, I have excluded the June, July, and August months. Under our conditions, these are the heat stress periods, and the study was, carried out in 3 Hungarian cattle farms. Either weekly or biweekly, we were doing pregnancy checkings, and parallel with the pregnancy checkings, we sampled the cows from the coccygeal vein. First pregnancy check was carried out between days 28-34 of pregnancy by two methods, either by a transrectal ultrasonographic examination or by a point-of-care lateral diffusion test. During the transrectal ultrasonography, in our practice, since now more than 1.5 decades, we are using 4 criteria for pregnancy. These are presence of the embryo, presence of the heartbeat, sufficient fluid amount around the embryo, and the presence of the corpus luteum, mostly on the contralateral or sometimes on the ipsilateral ovary where the pregnancy is. This was the first pregnancy check, and there was a second one, which was a confirmational pregnancy check carried out between days 57-63. So in the second month, it was carried out by manual palpation, where we were checking the asymmetry and the fluctuation of the uterus. The veterinarian workload was evaluated in minutes. On farm A, we assumed that one vet visit is just pregnancy testing, so the exact work is 60 minutes. On the other farms, it's 120 minutes. Exact work is meaning when we have arrived, we drink our coffee, we change into wetsuit and start working with the cows. Altogether, there were 2,760 minutes workload carried out. The farms were average Hungarian farms with an annual production of 10 to 13,000 kilograms. We have excluded those animals who did not have a complete ultrasound diagnosis at the beginning, so those animals who were not meeting the criteria of the 4 criteria of pregnancy were excluded from the data. And after pregnancy testing and blood collection, with 1 or 2 hours of car traveling, the blood samples were cooled in ice boxes, and in the university clinic we were carrying out the point of care pregnancy test after each pregnancy testing occasion. Let's see the results, what we got. Firstly, the clinical accuracy of the pregnancy test. First of all, the overall pregnancy rate out of the 637 animals was 42.9%, so which is a good result in terms of 3 farms, and there was no difference between the farms. Those animals who were positive with transrectal ultrasonography were almost in every case positive also with the point of care test. Just 1.1% of them, 2 samples, were negative. Out of the ultrasonography negative animals, we found 11% of the animals, of the 364 animals, which were still positive with the Alertis on-farm test. That's what I was talking about at the initiation. Always when I do ultrasonography and somebody comes sampling after me, when I found 100 pregnant animals, the test found 99, 98, 99, or sometimes 100 pregnant ones, depending on the sample size. But if we enlarge the sample size to thousands, there still will be some false negative animals. From these numbers, we were able to calculate the accuracy of the test, and I have distributed to animals to primiparous and to multiparous animals. We had 125 primiparous animals, and in terms of sensitivity and negative predictive value, the accuracy results reached 100, whereas in multiparous animals, it was somewhat lower, 2% lower. If we assume all of them, then in between, somewhere around 99% was the sensitivity and the negative predictive value. Because of the previously mentioned problems, the specificity and the positive predictive value was lower of the test, but that's the nature of the test that we already know. Regarding to pregnancy losses, because we have monitored pregnancy losses as well, the ratio of total losses was 8.7% between the first and the second month of pregnancy. Professor Baruselli previously just mentioned 18 and 20%. Our climate is not as warm as his. I think that's the source of difference. There was a difference between the spring and the autumn losses. It was statistically significant, and between farms there was no difference in terms of pregnancy losses. There was a strong significant effect of parity. It's worth to mention that the first lactation animals had nearly the same pregnancy loss rates as heifers, which is meaning that from herd management, reproductive herd management point of view, we can assume heifers, not totally, but from pregnancy diagnosis management, in the future we can think onto first lactation animals like heifers, because they can reach the same good results. And last but not least, from the results, we assumed a theoretical situation that the colleague just have mentioned, and that's where we are linking, that the farmer does the tests before the vet arrives, and just those animals are coming for transrectal ultrasonography who are negative in the test. The positive ones are kept as positive, will have confirmation of pregnancy diagnosis, but though if we theoretically examine just those animals who were negative with the IDEX-POC test, then the reduction rate is greatly differing in the three farms. Some farms can reduce 74%, while some farms can reduce up to 3%. So that will reduce veterinarian workload if we do it around that way. I still have a few minutes for discussion. So first of all, the accuracy results. In my meaning, or in our meaning, under clinical or practical circumstances, the accuracy is meaning the test accuracy itself and the pregnancy losses together. Because if the pregnancy loss is too high, then we have to evaluate it if there is an infectious or non-infectious cause, or wrong tests we are using, wrong veterinarian, wrong POC test, wrong technician, wrong ultrasound, or whatever. So it should be assumed. In the literature, up till date, the gold standard for pregnancy testing is the transrectal ultrasonography, whereas it's not an ideal method. So out of unlimited number of cows, there always will be somebody who should be called back, rechecked for the next week, because for a certain reason we are unable to say out. An ideal test is able at the same time point evaluate finally or every animal. Regarding to pregnancy loss data, I put up our own results in the last 15 years in Hungarian herds, which is varying between 5 to 15%. We do advise that if somebody has more than 15% pregnancy loss, then the method should be evaluated, the possibility of an infectious agent should be evaluated, or the whole reproductive management should be evaluated. This test was, just in a few papers, was already evaluated, and almost everybody found the same accuracy. What conclusion is coming from this? With other words, heifers can be managed soon with a chemical test. Okay, so the real question is that will there be need for veterinarians in the future? for that. And of course, as tests are improving, because we see now since 2-3 decades that the tests are improving, there will be more and more accurate tests possibly. The other part of the discussion is the possibilities of the herd level reproduction management. If we evaluated only the negative animals and the farmer tested with the point of care test, this whole thing, there was no pregnancy check omitted. So we still have to go there. There is a possibility to scan less animals and through this suffer less physical problems. But the reduction percentage is greatly varying on the estrus detection system, while in our case at farm 1 it was just a visual estrus observation, and in farm 2nd and 3rd there were automated systems evaluating the estrus. And I also greatly advise, it's not worth to mention here, but in Europe many vets are working with low number farms in different herds. When we are evaluating pregnancy accuracy results, we always advise to evaluate around 500 pregnancy testings in order to have sufficient data. I also would like to thank everybody, as first of all my university, for being here, for the granting, and to the organizers for accepting my paper. Thank you very much for your interest. If you have questions, I'm happy to answer.
Thank you. We have time for a question, if anyone have a question for the doctor. No? I think it's everything. Thank you, doctor. Okay, we are just on time for the coffee break, and we return at 11 o'clock. Thank you.
Is this working? Okay, it seems to be working. So this is the reproduction session. We will continue now with Dr. Alejo Menchaca. Dr. Alejo Menchaca, coordinator of the Animal Health Platform of the National Agricultural Research Institute. He is a DVM, an MSc, and a PhD. He serves as the Director of Animal Health Platform for the National Institute of Agricultural Research in Uruguay. He was a co-founder and served as president for 10 years of the IRAU, whatever that is, an organization dedicated for research and development in animal reproduction and health. He has held high-level management positions and served as a permanent consultant, thank you, for the veterinary pharmaceutical industry for different companies in the Americas and Europe. He has supervised and co-supervised over 30 postgraduate students in Uruguay, Argentina, and Mexico. He will be presenting the talk, Fixed-Time Artificial Insemination, with or without estradiol. 2 words on One Health. Thank you, Dr. Menchaca. Welcome.
Okay, good morning. Thank you very much for the invitation. I prefer this micro, but no problem. Thank you very much for the invitation. It's really a great pleasure to be here in Mexico. We will talk about one situation that we have here in Latin America, in some countries, mainly in Uruguay, that the estradiol in fixed-time insemination was banned 2 or 3 years ago. And so I want to tell you about this story in Uruguay that is also a problem probably for other countries. Some restriction that we have with estradiol in other countries. We don't know what will happen in 5 years, 10 years with this technology. For begin, I want to show you what is the situation of this technology in our country, where we come from and where we go. The revolution of this technology began with the use of ultrasonography to study the ovarian physiology 30 years ago almost, with pioneer works in physiology or reproduction in physiology of the ovarian dynamics, and these first studies demonstrates that follicular waves occurs in ruminants, in cattle in particular, and after that, with this information, different protocols were developed for superovulation and also for fixed-time insemination. And this technology grew a lot during this year, in 10 years, and with the ovarian control was possible to apply this technology in large-scale programs in all Latin American and also worldwide in different countries. We work in particular in our country with estradiol benzoato, estradiol benzoate, and cypionate in different protocols. This protocol was refined and were improved during some years, and now we are in some countries, in Uruguay in particular, with this problem. So how is the future of this technology? Probably this technology will grow in the following years. We will improve the calf production, probably with the use of 6 semen associated with fixed-time artificial insemination. So both technologies together will improve the cattle production in our countries. We need to maintain a simple and easy technique to be applied in field condition, in extensive condition. We need to ensure profitability of the farmers. this is the basics of any technology need. But also, we have a challenge that is respond to market demands. And in this context is that the use of estradiol is discussed. We are talking about the One Health approach that you know, where the health of the people, the public health is related also with the animal health and also with environment health. In this context, animal welfare is very important, environmental impact, the climate change that is discussed about, the effect of the cattle and livestock on these concerns. We need total traceability, and of course, we need to ensure the safety, because the food products that we are producing are very important for our people worldwide. In this case, the problems like residues, good practice in the use of veterinary products, the issue about antimicrobial resistance, and also hormone-free food, in particular the use of growth promoters, are problems that we need to confront and to solve. In this context of safety is that the estradiol was banned in some countries, or is not allowed in some countries, and for this reason I want to talk about that. So the first message is that fixed time insemination is expanding worldwide, but we should learn to adapt to evolving global market trends, to listen our consumers, to produce food safety and appropriate for these consumers. What's about the estradiol in fixed time insemination? Is really a risk for consumers? You know that we use this technology, fixed time insemination with estradiol. The conventional protocol in our country is the use of progesterone with estradiol benzoate during 7 days, 8 days. At time of device removal, other dose of estradiol cypionate is given here with ECG, prostaglandin. In some cases, we use tail painting to detect estrus or to identify the animals that are in estrus, to inseminate 2 days after device removal or in the day 9 from the protocol. This is the conventional protocol that we know, developed 30 years ago, at least, by Gabriel Bo, that is here, Pietro Baruselli, Roberto Sartori, people that worked a lot during several years in these technologies. How does the use of estradiol in fixed time insemination affect estradiol blood levels? In this study in dairy cows was demonstrated how is the estradiol levels after the administration of estradiol 70 beta, estradiol benzoate, or estradiol cypionate, comparing with, in this case, with cows that have not a follicles larger than 5 millimeters. So the estradiol in blood growth here, the levels, and about 10 picogram per milliliters, and after that fall the levels, and 2 days after the treatment, no significant difference are between the different treatments. So with the doses that we use in fixed time insemination with 1 milligram of estradiol, the levels are very similar than non-treated cows 2 days after the treatment. So this is a good result, a typical result when we treated animals for fixed time insemination. Also in beef cattle, we did this study some years ago in which we evaluate after device removal, after progesterone device removal in a fixed time insemination, how is the estradiol levels after 1 milligrams or 0.5 milligrams of cypionate estradiol at the time of device removal versus other group, control group, without estradiol treatment. So the levels also are very similar with the control group, and the maximum estradiol levels are very similar, about 10 to 13 picograms per milliliters in the three groups. So this is typical analysis that we need to induce ovulation and to pregnant the animals. So what about the estradiol in meat? Really represent any health risk to consumer when you compare with other food that we consume every day? In this case, comparing with different estrogenic compound in different foods, for example, in potatoes, in eggs, and the equivalent in the meat of a cow treated with estradiol for fixed time insemination. These values are estimated at the day after treatment. What happens if we slaughter the animals the day after treatment and we compare with the estrogenic compounds in different foods? The estrogenic content here in 1 kilogram of potatoes is the equivalent to 260 kilograms of meat. 2 eggs has estradiol compounds equivalent to 400 grams of meat. And the same with this other food that we consume every day. Soybean oil, for example, 5 milliliters is the equivalent to 85 kilograms of meat. So in a salad, 100 grams of salad, of this kind of salad, contain more than 3,000 nanograms of estradiol or estrogen compounds, and a Brazilian picanha, for example, with a heifer that was treated the day before the slaughter, 300 grams have 3 nanograms of estradiol, and so it's ridiculous to think about that the meat eaten after a treatment might have some problem with consumers. Moreover, if you compare the estrogen activity or the estrogen compounds in the meat or in the food, comparing with the estradiol that we produce every day, for example, a child or a woman that produce 500,000 nanograms per day, obvious, this is ridiculous with the content that we have in the food. This is the content in our body is greater, really greater than the content that we have in the food. So all the information show that the problem is not the estradiol in the food. The issue, the concern is other thing. It's a different thing that is not a technical or scientific problem with the use of estradiol in the meat. This is very important because we are eating this food that we produce. We are not producing for Europe or for North America. We are producing for us mainly, firstly. So this is a problem explained by a business, by a commercial barriers, other different things that affect our market, also our production system. So the second message is there is no evidence that estradiol used in reproduction, in fixed time insemination, and also in recipients for embryo transfer generate food safety concerns. The other question is, if we ban the estradiol, really is there any problem with this banning? Yes, of course, yes. We have a big problem here because we use this treatment in all the cows that we inseminate. Where are the cows worldwide in the planet? here in America, we have 35% of cows, and here in Latam, where we use estradiol in fixed time insemination, we have 25% of the cattle population. And probably we inseminate here about 35 million of cows with estradiol. All of you that use fixed time insemination use estradiol in your programs, and all the veterinarians in these countries also use estradiol in the fixed time insemination programs. So this is really a problem. And we have another issue that we production systems are very difficult because we work in extensive condition, in pasture-based condition, and in this case we work in an estrus. 80%, 90% of cows are in an estrus with low body condition score on pasture-based system with a lot of problem with dry season, with different problems that we have with El Niño, with La Niña, with every year is different. Each year is different to other, and we have different, very difficult to pregnant the cows in this condition. So for this reason, fixed time insemination is really important for us. And so what happens if the estradiol is prohibited, is banned, how it was in Uruguay 3 years ago? 10 years ago, for us, this was not a problem. This is our figure 10 years ago. No problem for us. This is a problem for Europe, because in Europe, you know that is banned from 28, also New Zealand. In North America, it not used estradiol, so it's not a problem for us. But 5 years more in the future, 5, 7, 8, 10 years, in what moment the problem arrive and the estradiol is banned, and so this figure also represents our situation 3 years ago. But my recommendation is that we need to be proactive and to work before the problem arrives. How we solve this problem in Uruguay? Because 3 years ago was absolutely banned, and nobody has this tool to work with fixed time insemination. I will show you some studies, some experiment in which we try to replace the estradiol with other strategies, with other alternative in cyclic cows and also in heifers, comparing with conventional protocols or with J-Sync protocol with lengthening the proestrus, extending the proestrus length. Each protocol that we evaluate and we compare may be compared with a conventional protocol. You know, this typical protocol in which we use estradiol benzoate and estradiol cypionate here, and in cyclic cows with more than 25 years of adjustment and improvement, only with 3 passes through the chute. So we need to compare new protocols with these traditional conventional protocols to know if we can obtain the same results. And in heifers, we prefer to compare these new protocols with the J-Sync protocol that was developed in South America, in Argentina, con Gabriel Bo, and also in Uruguay, and have more than 10 years of adjustment and improvement, and we use in heifer this protocol. So also with 3 passes through the chutes. The first question is what has been done in other countries, because if Europe is banned and also in USA, how was the protocol that they used in the past and now in the present? you know about the OPSYNC protocol with GnRH, prostaglandin, GnRH. This protocol, with the use of progestation during 7 days, improved the pregnancy rate, and this was the standard protocol used during probably 20 years or 30 years in North America, mainly in USA and also in Canada, not here in Mexico, that here in Mexican veterinary use the estradiol progesterone-based protocol. But this is an interesting alternative to be evaluated in our condition. But some years later, were developed other protocols, shorter protocols, 5 days protocols, and pregnancy rate is higher, is greater than 7 days protocol. So in different studies, like these studies, pregnancy rate was greater with 5 days protocol than 7 days protocols. And also in this slide is shown how these 5 days protocols improve pregnancy rate in comparison with 7 days protocol. These short-term protocols, the objective of this protocol is to extend the proestrus length. Comparing with the standard 7 days protocol with progesterone, beginning always with GnRH, in this case with the standard protocol, the proestrus length is about 2 days, 2.5 days. With GnRH and at the time of fixed time insemination, the co-cinch protocol. But in this case, with the shorter protocol, with the shorter term here with the progesterone treatment, the proestrus length is extending during 3 days, and this strategy improves pregnancy rate because the follicle grow more and the condition and fertility is higher with this protocol versus this other protocol. The problem with this protocol is, in this case, 2 prostaglandins are required, but the interesting thing is that pregnancy rate increased from about 10 points in these studies reported by Bridges and in Ohio State University some years ago. So this is a good protocol to be tested here in our condition to replace the use of estradiol or the estradiol-based protocols. When estradiol was banned in Uruguay, we evaluate in more than 6,000 cows and heifers these other protocols, different protocols, in a lot of fixed time insemination program, a lot of different protocols, different combination of protocols, and always moving the cows no more than 3 times. We want to maintain the 3 management of the cows, and we evaluate different here. At the beginning of the protocol, we evaluate estradiol benzoate, GnRH, progesterone injectable, nothing. At the time of the device removal, we evaluate or compare with estradiol cypionate the use of GnRH, the heat detection, or no use, nothing. Treatment with intravaginal devices for 5 days or 8 days, and with short proestrus length or versus long or prolonged proestrus length. Different things were evaluated in 3 months because the ban was announced, and we begin in September in our breeding season to do this experiment during 3 months to have the information for the next year. I will show only 2 or 3 experiments, not all of them, but in heifer, probably the most interesting study was this one with this number of animals, Angus heifers, in 6 programs that we evaluate in 6 replicates, compare different treatment with J-Sync protocol. You know, this protocol consists on 6 days of progesterone treatment with estradiol benzoate at the time of progesterone insertion. At the time of device removal, 1 dose of ECG, prostaglandin, and tail paint is performed to heat detection at the time of insemination 3 days later in the morning, in this case 60 hours after the device removal, and those animals that are in heat are inseminated here, and the others receive a GnRH here, are treated with GnRH, no estrus cows, no estrus heifers, and insemination is performed in the afternoon, about 72 hours after the device removal. The other protocol was the co-cinch protocol, in this case with 5 days of progesterone treatment, with GnRH at the beginning of the treatment, with the same treatments here at the time of the device removal, and the same time of insemination after the device removal. This split cinch is the name that we use because it's not a really co-cinch, because those animals that are in heat here, that is in estrus, are inseminated here without GnRH, and the other receive the GnRH, are inseminated some hours later. So it's not really a co-cinch. The animals are split in 2 groups, with or without estrus. The other strategy was to use injectable progesterone at the time of device insertion. You know that progesterone inhibits LEH pulsatility, and so the follicles regress. And with this in mind, we evaluate the use of progesterone injectable at the same time that we insert the intravaginal device. And the time of insemination was the same. Another group, nothing was used. In this case, no treatment, with only with the progesterone in the device. So we want to evaluate the effectiveness of different drugs, drugs to use here to emergent the follicular wave. The pregnancy rate in these different protocols is here. This protocol, this co-cinch protocol or split cinch protocol for 5 days was very similar to the pregnancy rate with our conventional protocol, our control protocol. So we have a nice protocol to work without estradiol, and this is a good result for us. The other groups, in both cases, pregnancy rate was decreased and was low for us. We evaluated this protocol also in cycled cows, in an estrus cow. In this case, only 16% of cows have a corpus luteum. The other, more than 80% were in an estrus. And we evaluate the conventional protocol here in cycled cow, that we use the conventional with 7 days of treatment with progesterone, with estradiol benzoate and cypionate here. And insemination in this case is 48 hours. This is bad, is a mistake. 48 hours after device removal, the insemination is performed here, and the other cows, no in estrus, are inseminated in the afternoon, 56 hours after device removal. We compare this with the same protocol that we evaluated in heifers and for 5 days, but here with 2 prostaglandin, and here the same protocol with 6 days, with the aim to avoid the use of 2 prostaglandin, because this second prostaglandin is used, the double doses of prostaglandin is used because the corpus luteum here, induced by the GnRH, is very young and probably is not sensitive to prostaglandin. For this reason, it uses a double doses. But if we extend the protocol 1 day more, probably this prostaglandin, this double prostaglandin is not necessary, and we can use only 1 dose. For this reason, we evaluate this protocol also. And pregnancy rate was very high in both treatments. This is a good news, a good result for the split zinc protocol with the same pregnancy rate that the conventional protocol. The bad news is that we need 2 doses of prostaglandin to maintain the 5 days protocol with 2 doses of prostaglandin in cycled cattle versus this protocol of 6 days with only 1 prostaglandin. So in the first year, we have this result. We decided to use, GnRH at the beginning of the treatment, GnRH as ovulation inducer. We maintain the use of tail painting or to know which cows are in estrus and inseminate them earlier than the other cows that are not in estrus. We maintain the treatment by 5 days with a long proestrus length. This was our first conclusion during first year. But the following year, without estradiol in the market, we evaluate other things to adjust or to improve this protocol. Some of the questions that we answered at that moment are here, and we evaluate in different experiments with a lot of cows in the next year. And one of the questions was if GnRH is really necessary in heifers here, or if we can improve the response of this first GnRH, because you know that heifers, the response of heifers to GnRH is low, is very low, because most of them don't ovulate after the treatment, because the follicle is very small, and you know that this is a problem. So some researchers in Canada mainly propose no use GnRH here, and others propose to apply double doses of GnRH at the time of device insertion. So we evaluate here 3 groups, one with 1 dose of GnRH, other group without GnRH, another with double doses of GnRH. We worked in this number of animals, Angus heifer in 6 replicates, 50% more or less with corpus luteum, the other in an estrus. And in 3 groups, so one was all of them with 2 doses of prostaglandin. At the time of the removal was the first, and the other was in the morning of the following day, 14 hours later. But here, without GnRH, 1 dose of GnRH or double doses of GnRH using buserelin. In this case, the control group was here with 8 micrograms. And pregnancy rate is here, was higher pregnancy rate with a control group with 1 dose. The typical dose of GnRH was higher than this group without GnRH. So GnRH is necessary, is required, and double doses of GnRH in our case did not improve the pregnancy rate. So it's not necessary to add more cost to the treatment, and we maintain only one GnRH with a good result, very good results in pregnancy rate. The other question, also in heifers, was the use of prostaglandin at the time of device removal. You know that the problem with the prostaglandin here is that the corpus luteum, after GnRH, the GnRH induced the ovulation here about 1 or 2 days after the treatment, and so the corpus luteum here at the time of device removal has only 4 days of age, 4 or 5 days. So the sensitivity of the corpus luteum to prostaglandin is low, and for this reason is required 2 doses. A double doses at the same time, or 2 doses separately, or only 1 dose. For this reason, to answer this question, we evaluate in 2,000 heifers, 50% more or less in an estrus and the other 50% cycling. And we evaluate 3 groups, one with only 1 prostaglandin, 2 prostaglandin at the same time, or 2 prostaglandin separated. The same protocol, 5 days of the co-cinch or split cinch protocol, and the same system for insemination on day 3 after the treatment. And pregnancy rate was very similar between the 3 groups. This is the pregnancy rate, about 50%. So the conclusion of this study was that we prefer to use only 1 prostaglandin because pregnancy rate is the same. It's not necessary to use double doses at the same time or separately. With only 1 dose is enough to have a good result. What happened in cows? In cyclic cows, we evaluated the same, but in cyclic cows also with more than 2,000 cows, Angus cows. These are one of the groups. We evaluated in this case with 8 replicates in different fields, in different farms. And in this case, we evaluated only 2 groups, only with double doses at the time of device removal, and the other with 2 doses separately. One of them used at device removal, and the other in the next morning. The device was removed in day 5 p.m. and in the morning, the next morning was administered the other prostaglandin dose. And the insemination was performed 3 days later in the morning, about 60 hours, those animals that were in estrus, and when estrus was not here, the animal received gene react here in the morning and were inseminated in the afternoon. Pregnancy rate is here and was improved by the use of 2 doses of prostaglandin separately. So this is a good question for us because we need to use the second prostaglandin separately in comparison with the use of the 2 prostaglandin at the same time. But 10% is a lot. We prefer to do this administration separately from the other. When we evaluate in different replicates, almost all the replicate pregnancy rate was greater here with 2 doses separately compared with the double doses at device removal. In this case, only here was similar, but in the others, some point in favor of the 2 doses separately was found. And for this reason now in cycled cows, we are using the 2 doses at device removal and the other in the next morning on day 6. So with this protocol, our conclusion are that GnRH is necessary in heifers. Double dose of GnRH at the beginning is not necessary. With a single dose is enough. Prostaglandin, double doses is required in cyclic cows, and this prostaglandin will be administered after device removal, the second dose. We prefer to inseminate the animals in heat in the morning, 3 days after device removal, and the other inseminate the animals without estrus in the afternoon with GnRH in the morning. We maintain this scheme of insemination, and we are working to study if we can improve this management. We have a lot of animals evaluated for validation of this protocol. We have here some veterinarians from Uruguay that are here, and most of them use this protocol with GnRH, with this same protocol that we see here. with good results. It's normal for us to use this protocol in our condition. We maintain 3 passes through the shoot. Even we need to add 1 prostaglandin, but the management of the animals are maintained in three big times. And the pregnancy rate is acceptable in our condition in Bostaurus and in this condition that I show with you. We have a lot of animals evaluated, and this is the protocol that we are using in heifers and also in cattle with GnRH here, progesterone, 5 days, ECG, 200 international units in heifer and 400 in cows. Prostaglandin, only 1 dose in heifer and 2 doses separately in cycled cows. The device is removed on day 5 in the PM. We use tail painting, and on day 8 in the morning, we evaluate the paint of the tail, and in this case, when the animals are in estrus, are inseminated in the morning, and without estrus, receive GnRH in the morning and are inseminated in the afternoon. So this is our tool that we have now. So the last message is, even without estradiol, almost in our condition, at least in our condition, fixed time insemination can be applied with success in beef cattle. We all wish this never happened, but if happens, we need to be proactive to evaluate different conditions to be advanced, because if you maintain this position, our position in the past, if the problem arrives, probably you don't know have the solution quickly. So this is all. Thank you very much for your attention.
We have time for a couple of questions. If you please raise your hand. Okay, over here.
Congratulations, Alejo. This is very important. Apportation for all around the world of the problem we have there, for make the most good production, more quantity of food. Yes. My question is about is the difference of the pregnancy rate with the no-heat females with GnRH and inseminate after 10 hours. What is a low pregnancy rate or is good pregnancy rate?
Okay, the question if it's necessary to give the GnRH separately of the insemination, because the pregnancy rate with cows or heifers not in estrus is lower than those cows that are in estrus. We know that.
Okay.
If we give the GnRH at the same time that insemination, not with this protocol, we are evaluating that now, but with the J-Sync protocol, with the other protocol with the proestrus length that we used in the past, pregnancy rate is improved when we use GnRH in the morning and inseminate in the afternoon. If we use together GnRH with insemination in the morning or both in the afternoon, pregnancy rate is lower than this strategy to inject in the morning and inseminate in the afternoon. For this reason, we maintain this scheme with this new protocol, with this co-sync protocol, and we prefer in those heifers that are not in estrus, give the GnRH in the morning and inseminate in the afternoon. But we are evaluating with this protocol, further evaluating this strategy. But now we recommend this scheme.
Okay. Anyway, if we have low fertility in those females, we have fertility. So we have pregnancies. Okay.
Yes, yes.
Okay.
The difference is about 5 to 10% in comparison with those heifers that, or cows that are in estrus.
Yes.
But we have more than 40% of pregnancy in these cows or heifers. Always we evaluate the animals before the device insertion by ovarian ultrasonography. Okay. Those animals that are in deep anestrus without follicles greater than 8 millimeters are discharged, are not included, heifers or cows, cyclid cows.
Okay.
This is not more than 10%, more or less, of the animals. Hmm?
Okay. Thank you.
Thank you. I'm sorry, we will have to move on. Sorry for that. We thank Dr. Alejo Menchaca for his contribution, and we give him Right, we continue with the session on reproduction. Our next talk will be presented by Ana Laura Lapacette from the United States.
Yes, I'm from Argentina, but I'm in the United States now. Thank you all for attending. Thank you for the opportunity of being here, presenting our research. So I would like to start introducing the concept of reproductive target management. That is a topic in which our lab has been working a lot for the past years. It basically consists on identifying identifying individuals that share a similar reproductive, a different reproductive or performance potential by using multiple traditional and novel sources of biological, performance, or management data as predictors. This allows us to create subgroups of individuals that share similar reproductive or performance features to implement specific reproductive management strategies to optimize the performance, the herd profitability, or alternative outcomes of our interest. In particularly, in today's presentation, I will focus on the use of sensor data as predictors to create the subgroups of predictive potential to implement target management. The overall objective of implementing target reproductive management is to generate greater gains by tailoring these specific subgroups with reproductive management strategies based on their potential instead of using a whole, the same strategy for the whole herd. Automated monitoring systems represent a source of data for prediction of reproductive potential, and data generated by sensors can be used in different manners to generate the subgroups of individuals. Among these manners, there are three that can be listed and that we have been working on. First of all is the record or the use of discrete biological events, for example, estrus and estrus event, through the detection of automated monitoring systems. Then a second one is to use features of discrete events, such as, for example, intensity of an estrus alert or duration of an estrus alert. And then the last one is to use sensor pattern parameters features that have been associated with reproductive performance. Again, today I will focus on the use of discrete events, particularly automated estrus alert during the voluntary waiting period as a predictor to identify individuals with similar reproductive potential. This approach is supported by previous research that in which cows that had an automatic estrus alert during the voluntary waiting period were more likely to receive insemination at detected estrus after expressing estrus at the end or after the end of the voluntary waiting period. In addition, cows that had an estrus alert during the voluntary waiting period had a greater first service pregnancy PRI, reduced time to pregnancy, and a greater proportion of cows was pregnant by 150 days in milk. Therefore, records of automatic estrus alert during the voluntary waiting period could be used to identify these animals with different potential to create the subgroups to implement target reproductive management. For example, cows that express estrus would be more likely to express estrus again, and therefore could be better candidates for programs that favor insemination at detected estrus. Whereas cows that do not express estrus during the voluntary waiting period and would be less likely to express estrus after the end of the voluntary waiting period would be benefit for programs that favor time AI. Based on the known association of estrus expression during and after the end of the voluntary waiting period, these two research teams, one from Wisconsin and the other from our lab, evaluating a first service program that used combined insemination at detected estrus and time AI, giving two different lengths of detection of estrus to cows that express estrus during the voluntary waiting period, and a shorter period for cows that did not express estrus during the voluntary waiting period. After this time, cows that were not inseminated at detected estrus were synchronized to receive time AI. This approach was compared with a first service program that used all time AI, and therefore cows were not eligible to be inseminated at detected estrus, and that were received time AI after an extended voluntary waiting period, and to a combined approach that used insemination after estrus detection during a standard time for the whole herd, and synchronization of ovulation for the cows that were not inseminated. Results from these two experiments reported that there was no difference between the pregnancy dynamics of these programs, and that they led to a similar time to pregnancy and a similar proportion of cows pregnant by 300 days in milk and 150 days in milk. We were interested in adding more evidence of the performance of target reproductive management programs in different situations and conditions, and also to better characterize the difference in physiology of cows that express estrus and do not express estrus during voluntary waiting period, and to evaluate the association of the estrus expression during the voluntary waiting period with the reproductive performance. And therefore, we hypothesized that a target reproductive management program that combined the use of insemination after estrus detection and time AI by giving different lengths of detection of estrus to cows that express and do not express estrus during the voluntary waiting period would result in a similar pregnancy dynamic that a program that used all time AI and an extended voluntary waiting period. In addition, we hypothesized that cows, lactating dairy cows that express estrus during voluntary waiting period would be associated with an improved reproductive performance after being submitted to both programs that use all time AI and programs that prioritize insemination at detected estrus based on estrus expression during the voluntary waiting period. During the first presentation, I will focus on the primary hypothesis, and we will talk further about the second presentation. In order to test our hypothesis, we conducted a randomized control experiment in a commercial dairy farm in Tequisquiapan here in Mexico, and in which all cows were fitted with a sensor for automatic estrus detection prior to calving. 1 week after calving, cows were blocked by parity and the type of semen assigned for first service, and they were randomly assigned into one of two experimental treatments. The control treatment was a program that used all time AI, in which all cows received a double synchronization of ovulation protocol and received TAM-AI at 76 days in milk, approximately. Cows were not eligible to be inseminated at detected estrus in this protocol. On the target reproductive management program that prioritizes insemination, I will call it from now on target program because it's too long. Cows that had at least one automatic estrus alert during the voluntary waiting period were eligible to be inseminated at detected estrus for a longer time that was of approximately 4 weeks. And if were not inseminated by that time, they were submitted to an opt-in protocol with progesterone supplementation to receive TAM-AI at 90 days in milk, approximately. For cows that did not express estrus during the voluntary waiting period, cows were given a shorter time for insemination at detected estrus, and then, if not inseminated by the end of that time, they were submitted to the same protocol to receive TAM-AI at 76 days in milk. All cows had automatic estrus alert from 15 to 49 days in milk recorded, and they were followed up to 150 days in milk to collect data to evaluate the repro performance, and all second and subsequent services were followed the same program in both treatments. There were no difference after that. So our outcome of interest were the proportion of cows with automatic estrus alert during the voluntary waiting period, that is coded with the number 1 over there. Then the proportion of cows that was inseminated at detected estrus in the target management program, the first service pregnancy per AI, and then time to pregnancy and the proportion of cows pregnant by 150 days in milk. Our explanatory variables were the treatment, the estrus group, and the interaction between these two variables. Estrus group is the name that we gave the subgroups of cows that we create by identifying the cows with the automatic estrus alert during the voluntary waiting period. From now on, cows in yellow and with the abbreviation estrus during the voluntary waiting period will be the cows that had an estrus alert, and in orange and with the abbreviation non-estrus voluntary waiting period will be the cows that did not have an automatic estrus alert. So in this figure is the proportion of cows that express estrus during the voluntary waiting period, and it can be seen that there was no difference between treatment, no hormonal interventions or any treatment was given during the voluntary waiting period, so we were expecting no difference. By experimental design, all cows in the control treatment were not eligible to be inseminated at detected estrus, but on the target management program, approximately 70% of the cows receive insemination at detected estrus. Before moving on, I'm going to talk about this later on the second presentation, but it's important to say it here again that there was a difference, a significant difference in the proportion of cows that was inseminated at detected estrus that had an automatic estrus alert during the voluntary waiting period compared with the ones that did not. So there was a 40 percentage point difference, 83% against 45% of the cows were inseminated at detected estrus. So in addition, days in milk at first service was reduced for the cows submitted to the target management program, and the difference was on average of 1 week. Similar to previous the experiments that I talked about during the introduction, the pregnancy per AI of the old TAM-AI treatment, of the control treatment, was greater than for the target management program. And in red is the group that has the lower pregnancy per AI that corresponds to the cows that did not have an estrus alert during the voluntary waiting period and that were submitted to the target management program. The rest of the groups did not have difference in first service pregnancy per AI. In this table below are cows in the target management program, and it can be seen that the lower pregnancy per AI correspond to the non-estrus group, but also that this lower pregnancy per AI was either for the cows that were inseminated at detected estrus and that were submitted to TAM-AI. There was no difference in first service pregnancy loss between the treatments. And for second service, there was no difference in the proportion of cows pre-inseminated at detected estrus. However, days in milk at second service was reduced for the cows that were submitted to the target management program, being re-inseminated on average 12 days earlier. The pregnancy per AI did not differ between treatments for the second services. And then in this curve, it's shown the time to pregnancy of the two treatments, and overall, there was no difference on the time to pregnancy between the control treatment and the target management program. Median days to pregnancy were 102 and 107 days. And this is kind of to separate the results or to go through the graphic together, but in red, now is the difference in area of the curves. So before the first service of the control treatment was completed, at least 20% of the cows on the target management program were already pregnant. When the TAM-AI was completed, due to the first service pregnancy per AI of the control treatment, the proportion of cows pregnant was greater for the control treatment. And then by 90 days, due to the earlier re-insemination dynamic of the target management program, the pregnancy rate started being similar and stayed the same until the end of the study period. And there was no significant difference on finally on the proportion of cows pregnant by 150 days in milk. So in support to our hypothesis, a target management program that combines the use of insemination at detected estrus and TAM-AI by giving different length or periods of detection of estrus for cows with and without estrus detection during the voluntary waiting period resulted in a similar pregnancy dynamic that a program that used all TAM-AI and an extended voluntary waiting period. So the target management program resulted in a higher proportion of cows inseminated at detected estrus, minimizing the submission of cows for TAM-AI, and giving different periods or length of detection of estrus, prioritize the submission to TAM-AI for cows that would be more likely benefit for the use of TAM-AI. And this approach might be an alternative for those farms who want to minimize the use of hormonal interventions in their management programs. As future research, or the research that we are currently working on, we have learned from this experiment that targeted reproductive management programs rely on pregnancy per AI and the proportion of cows inseminated at detected estrus. So we are working on developing alternative management strategies to target these subgroups of cows identified by automatic estrus alert that have demonstrated that it's a good predictor of reproductive potential. And with that, I want to thank you all for attending, MSD that supported the research, and among with other institutions that collaborated, the Commercial Dairy Farm and the Dairy Cattle Biology and Management Laboratory.
Thank you. Nada más tienes 10 minutos, te llevaste 20 minutos ahorita. Entonces, corta la introducción y vete directo a las presentaciones.
Okay.
Si puedes.
Sí, sí.
Right, next talk is presented also by Ana Laura, and so I let her continue, and we have the questions after the next talk.
Okay, so now I will focus on the results that led to the answer of the second hypothesis. I will go through this part fast because we are running out of time. But the secondary hypothesis was that if lactating dairy cows with automatic estrus alert during the voluntary waiting period are associated with an improved reproductive performance, either after submission of programs that use all-time AI or that prioritize insemination at detected estrus. To evaluate this, our objectives were to evaluate the expression of estrus detected by automatic monitoring systems and the association between these and cow physiological features and reproductive performance. So I will not repeat the design, but we collected physiological data during this experiment. Basically, we collected body condition score in 6 different time points on a scale of 1 to 5, from the time of the move to the close-up pen, calving, first week after calving, time point that represent the middle of the voluntary waiting period, and the end of the voluntary waiting period. That was collected on all the cows. Then on a subset of cows was evaluated locomotion score. Blood was collected to evaluate the circulating concentration of progesterone, and vaginal discharge scores were also evaluated. We determined if there was or not a body condition score change between the time of calving and the end of the voluntary waiting period, classifying the cows according if they have gained, lost, or maintained the body condition score. Then we determine or we identify if the cow had had a lameness, if at least had one score greater than, equal or greater than 3 in each one of the time points. Then we classify the cow if she had been cyclic or not cyclic during the voluntary waiting period by if the cow had at least 1 nanogram per milliliter of progesterone in one of the 2 time points. And then we classify the cow as having had purulent vaginal discharge if had a score of 3 or greater in at least one of the 2 time points. So we were interested in evaluating the effect of different features or factors on estrus expression during the voluntary waiting period. These factors were predicted transmissibilities of DPR, of daughter pregnancy rate, then calving ease, calving season, the presence of health disorders during the 2 weeks after calving, and we evaluate the effect of this on the proportion of cows pregnant, on the proportion of cows with estrus expression during the voluntary waiting period. And then we evaluate the effect of estrus expression during the voluntary waiting period on the same reproductive performance outcome that we measure, and I explained during the first presentation. So this is the proportion of cows that express estrus during the voluntary waiting period. Almost 60% of cows express estrus. More cows that calved in the cold rather than the warm season that did not have a health disorder during the first 2 weeks after calving, and that were in the high group of DPR had automatic estrus alert during voluntary waiting period when compared with the other groups. Here we evaluate the change of body condition score in cows that express and did not express estrus, and it can be seen that cows that had an estrus alert during the voluntary waiting period had greater body condition score from the first week after calving to the end of the voluntary waiting period. In addition, more cows that maintain body condition score that did not have lameness and that did not have purulent vaginal discharge were associated with automatic estrus alert during the voluntary, or with estrus expression during the voluntary waiting period. More cows that had an estrus alert during the voluntary waiting period were defined as cyclic at the end of the voluntary waiting period. And returning to the first pregnancy or insemination dynamics, more cows with estrus expression during the voluntary waiting period had received insemination after estrus detection. So more cows with automatic estrus alert express estrus again after the end of the voluntary waiting period. In addition, more cows with estrus expression were pregnant after first service, so the pregnancy period was greater, and the proportion of cows with pregnancy loss was lower when compared with cows that did not express estrus. For second services, the proportion of cows that was pre-inseminated that detected estrus, the days in, and was greater for the cows that expressed estrus. Days in milk at second service was reduced when compared with non-estrus cows, and the pregnancy period after second service was greater also for cows with estrus during the voluntary waiting period. This graph analyzed the time to pregnancy for all the cows together, either if they receive the control treatment or the target management treatment, and it can be seen that for cows in yellow that express estrus in the voluntary waiting period, time to pregnancy was reduced. Median days to pregnancy were 95 against 133, so it was over 35 days difference in the time to median days to pregnancy. The proportion of cows pregnant by 150 days in milk was greater for cows with estrus expression during the voluntary waiting period, and the number of services during the study period was reduced for the cows that express estrus until they become pregnant. These results were also repeated or were also similar when we analyzed the two management programs separately. So for cows that receive the old-time treatment and for cows that receive the target reproductive management program. With this, in support of our secondary hypothesis, cows that express estrus during the voluntary waiting period were associated with an improved reproductive performance and absence of purulent vaginal discharge, absence of lameness and health disorders, higher body condition score, and then maintaining body condition score during the voluntary waiting period were associated with or more likelihood to express estrus during the voluntary waiting period. So these multiple associations between cow features and physiological parameters with estrus expression suggest that a combination between estrus expression and other factors can be used to create the subgroups for target reproductive management. And in that line, Clara Rial from our group has reported that when using a combination of estrus expression and other factors such as milk yield, genomic daughter pregnancy rate, and absence or presence of health disorders during the first weeks after calving to identify the cows with different potential and create these subgroups, the difference in the reproductive performance, in the predictive reproductive performance, was larger than when creating the subgroups using those factors individually. So we are currently working on using combinations of factors plus estrus expression to create subgroup for target reproductive management. And last, this experiment adds more evidence of the ability of estrus expression during the voluntary waiting period as a predictor of reproductive performance and suggests that it could be used to create the subgroups for target reproductive management. And last, I want to add that even though these groups have focused on the estrus expression during the voluntary waiting period, we also have been working on estrus expression before insemination, after synchronization of ovulation, both in cows submitted to double opsin protocols and in cows submitted to developing protocols with delay induction of ovulation that promotes estrus expression, and those results also shown an association with potential reproductive performance. And with that, again, I want to thank you all for attending again.
A esa luz, por favor, un poquito. Gracias. Gabriel, sí, Gabriel, ¿quieres hacer una pregunta?
Hello.
Hello.
Thank you very much for the presentation. I think it's the present and the future to target the fertility in every farm. But I have a question about cooling decisions, because some farmers might decide not to wait up to 100 days in milk to breed cows. So is there a way that you can predict animals for do not breed using this targeted system instead of wasting and waiting and wasting more money until you make that decision later on?
Yeah, so I don't have the evidence, but I think what it should be done is to study the association of this predictor with the cooling rate, maybe like to be sure, because here we have been focusing on pregnancy dynamics. So I think if we focus to study the association between estrus expression and cooling dynamics, maybe we have a better answer about that.
Thank you.
Thank you. Oh, sorry. I thought he was decisively going for the microphone and just passed it.
Well, you pretty much forced me to come here, right? That's okay. Well, first, congratulations for the presentation. It's very nice work. And I have a couple questions. One is very practical, and the other one is related to the protocol. And what do you think? The first one is, it's an economical question about target breeding or using fixed-time AI. I know that Julio is very good on doing economics. And have you worked out the economics of doing either target breeding, considering the investment that you had to do for the sensors and all that, to what other people are just doing, which is just fixed-time AI, especially considering that you didn't have a significant effect. So you are reducing the number of hormones, but now I'm trying to be the devil advocate here, and I say, well, but if you use the hormones, you actually did not show an effect on time to pregnancy.
Yeah, so unfortunately, we did not run the economical analysis because one of the things that we were lacking was milk data of this farm. So I think that was an important factor that we, at least in our lab, economical analysis, we always have in mind. And I agree that we should keep evaluating this and being clear on the economical differences. What we are sure about is, or not sure, but what we think is that this gives an alternative for farms that are looking for an alternative for old-time AI protocols. And they result in a similar, if the farm is looking for inseminating more cows in earlier days in milk and getting to their outcome of interest is getting cows pregnant by mid-lactation. So this is an alternative, and it's a good alternative. More if the farm already have the sensor, that it was the situation of this farm, so they were happy about that. But yes, to answer that question, we need to run the economical analysis of this experiment.
Okay. The other question is related to when you chose the protocol for the non-estrus cows.
Yes.
well, as well as the cows that show estrus, you decided to use a progesterone releasing device.
Yes.
And that's because you were assuming that many of those cows were anestrus, and you thought that might be better to use a progesterone releasing device.
Yes.
Okay.
We use the same protocol in both in estrus and non-estrus cows, but then even in the retrospective analysis of cyclicity, we had a lower proportion of cows cyclic at the end of the voluntary waiting period in that group of cows. So that was why.
Gracias, Gabriel. Ana Laura, muchas gracias. Right. I'll pass now the microphone to Dr. Ali Fouladi from the Royal Veterinary College, London, to continue as chairperson.
Thank you, Robert. Thank you, Carlos. So our next speaker is Dr. Fergus Hannon from University of Nottingham in the United Kingdom.
Good afternoon, everyone. So what I'd like to discuss for the next few minutes is some work that I've been doing as part of my PhD program, looking at how we might use transition cow performance to predict an animal's subsequent fertility, specifically dealing with animals that are being milked through automatic milking systems. And what I'll hopefully highlight over the next few slides is some of the difficulties we have with predicting reproductive performance, but also the potential that AMS data offers to make those predictions. And while I'm going to chat about how we harvest sensor data and then we apply machine learning algorithms, I just want to point out before we start that predicting a cow's fertility is something that producers do on a daily basis, right? So whether they know it or not. And that might be something really simple, like a producer sees a cow in early lactation and he thinks she's lost a lot of condition. And when she comes into estrus, he decides he's not going to serve her, he's going to give her another cycle. And he's doing that under the assumption that her probability of conception is quite low, given that she's in negative energy balance, so he's going to wait. And that scenario, or a scenario very similar to that, I think is something that we will all have seen on farm. If we wanted to kind of formalize that decision-making process, it would come back to what Ana Laura has been speaking about, which is targeted reproductive management, okay? So we're taking a piece of information about that cow, in this case, low body condition score. We're going to use that to classify her expected reproduction. So we're going to say, no, we think she's going to have a low probability of conception. Then we're going to make a management decision and say we're not going to inseminate her. So these things happen every day on farm, and it doesn't necessarily have to be overly complicated. But in the environment we're in now, we have a huge amount of data available on dairy farms. So a reasonable question might be, can we use some of this data and apply machine learning algorithms to make predictions about a cow's fertility outcome? And that's what we were interested in investigating. So when we think about collecting data about transition cows, it's very, very difficult to top what automatic systems can offer. And that's not just in the volume of data they collect or the variety, but in how quickly they can get that data to us. So this is the first data set that we analyzed. These are variables that are collected by the robot block itself, and they're all available in real time from the day of calving. And so what we wanted to investigate was, when we collect this data over days 1 to 21 in lactation, can we first establish what the relationship is between these variables and reproductive outcomes, and then thereafter, can we use that to actually predict what that reproductive outcome is going to be, how well she's going to do. So we looked at two outcomes in particular: expression of estrus within the voluntary weight, which was days 22 to 42 in this study, and conception to first insemination. And we looked at this over about 9,000 lactations from 25 herds in the UK and the Republic of Ireland. So before we got to the predictive side of things, we just, as I said, wanted to look at the association between these variables and reproductive outcomes. So all the variables in red had a significant negative association with their respective outcome, and those in green had a positive association. And while I'm not going to go into this in too much depth because it wasn't the main focus of this study, it lets us kind of build a picture about the relationship between AMS data collected during transition and subsequent reproductive performance. And it gives us a bit of confidence in the data set that we're using, in so much that kind of all the old reliables are up here. Okay, so markers of negative energy balance are important, markers of udder health are important, and milk yield is important. So that's kind of in line with what we would expect. But the significant association that we can demonstrate, it doesn't actually tell us anything about how well this data might predict an animal's outcome. So to do that, to look at that, we built random forest models for each outcome. And once we trained those models, we went and applied them to a completely new data set. So kind of herds that the models had never seen, to kind of see how these models would perform in the wild, per se. And when we did that, as you can see, if you look at the sensitivity and the specificity here, this data didn't allow us to make overly accurate predictions when we asked it to differentiate an animal that was going to have fertility success, so it would express estrus within the voluntary weight, or conceive. If you look at the AUC-ROC here, so that is just a kind of a general measure of predictive performance, where 0.5 is the baseline. So a guess will get you 0.5. You can see that our conception to first insemination model performs very, very poorly, right, just above baseline. We did see a much better performance from our expression of estrus, but still not quite as high as we'd like. But one of the advantages of dealing with AMS data is that there's so much of it, right? There's always more variables we can offer these models to try and improve predictive performance. And so that's what we went and looked at next. So we had our original core data set that comes off the robot. And then what we wanted to look at was what happens to the predictive power if we add 3 auxiliary pieces of data. So what we looked at adding was rumination and activity, so that was coming off a neck-mounted accelerometer, a sense hub. And then some details about the animal's prior performance. So her age at first calving, her prior fertility performance, prior milk production. And the idea here was, if we can offer more data to the model, we'll hopefully be able to build a more comprehensive picture of that animal, and then hopefully get a more accurate prediction at the end. So using a subset of our original data set, we went back and we built 2 random forest models for each outcome. And we wanted to compare how the original AMS models, using just the core data set, compared with the AMS plus models in gray. And we can see, we still see a small increase in accuracy, but nowhere near what we'd like, really. So those variables that we added, they did give us increased predictive power, but still not where we would like it to be at the individual animal basis. And this is kind of par for the course when it comes to predicting fertility at the individual level, right? It is very, very difficult to predict if this cow will become pregnant to this exact insemination. But the question remains, how would this work if we were to implement it into something like Anna Laura discussed, which was a whole targeted reproductive management strategy? So when we look at implementing these models into a TRM, what we're worried about more so than the individual animal is actually, can we group animals? So from a management perspective, what we're after is if we can group animals, let's say, into those that are going to be very lowly fertile and those that are going to be extremely fertile. And that allows us to then generate management strategies that are group-based. So to give you an example, we might take our animals that are predicted to have a very high conception to first insemination probability, and we can then target those animals with sex semen. And on the other end, if we have animals that are expected to have very low probability of conception, well, we can target them with beef semen rather than with something like an expensive sex semen straw. So when we look at the predictive accuracy for our AMS plus models for EO and CFI, so both in gray, what we can see is that these models do a very good job of picking out those poor animals. So those animals that are going to perform very, very poorly over their reproductive outcome. And this is quite good, and that there's value for producers in that to be able to pick those animals out. The issue is when we look at the opposite end and we look at the high percentage of animals. So low, sorry, I should have explained, but low is the bottom 25%. High is the top 25%. And obviously we have a lot of animals in the middle, but it's these two edges that we're really worried about, because that's where we can really target our reproductive intervention. So the models perform very, very well when they're asked to identify animals on the low end, but when they're asked to identify animals that are highly fertile, they still struggle. So these models, they're by no means the finished product. You know, this is preliminary work, and it's something that Anna Laura and the guys are all working on as well, and it's a really interesting area of development. And when we think about how these models might work going forward, I'll just leave you with 2 points of how we might see these come into play in the future. So the first is kind of cautionary, and the second maybe a bit more optimistic. So we saw an improvement in our models when we increased the number of variables that we used. And it can be very tempting then to think, right, well, we're just going to keep adding and adding more and more data, and hopefully that will increase the predictive power that we can get. But I think it's important to highlight that there is a cost to increasing to adding variables to these models. So our goal is to develop a generalizable model that can be used on a four robot farm in Mexico, a 20 robot farm in the US that maybe, let's say, has bought the robot and all of the sensors, all of the sense hub gear that goes with it, so has a huge amount of sensors and generating a huge amount of data. But we also needed to work on a one robot farm in Ireland where the producer bought the robot but didn't buy all the extra sensors that come with it. So it can be really tempting to try and build really complex models and to chase accuracy, to try and get a model that's 99% accurate. But one of the barriers to developing these models is we need to keep them simple enough that they can be deployed on a wide range of farms. On the optimistic side, we have to think about why are we making these models? Why are we developing these models at all? And it comes back to targeted reproductive management, right? We're developing them so that they can be used within this targeted reproductive management structure. And the goal of TRM is so that producers can make better decisions about how they manage fertility on their farm. And as I said at the start, these decisions are being made every day, often with little more than gut instinct or maybe a single subjective data point, like I think that cow has lost body condition, so I'm not going to inseminate her. So we don't need for these models to lead us to the right decision 100% of the time to be useful. They just need to allow us to make more right decisions than our current decision-making process is. So while there is absolutely some more development to go into these models, I think there's a huge amount of potential in how they can be used, and I think you can say with confidence that they will be applied on farm in the not too distant future and play a larger and larger role in how we manage reproduction. Thank you very much.
Thank you, Fergus. Very interesting talk. Do we have any questions for Fergus? Okay, maybe I start one question. Fergus, you mentioned the basic data showed the sensitivity was about low, yeah, and with some changes could increase to like 30%. So what is your aim to achieve the sensitivity level that would be happy?
Yeah, it's a good question. So I've presented sensitivity and specificity here with the AUC, ROC, and you know, anyone in the audience who's working with machine learning models will know that that's a very, very narrow set of metrics to present, okay? So what are the real important metrics when we're looking at these types of models? For the most part, I would, rather than being focused on sensitivity, which I have included here for simplicity, but I think we need to be more focused on things like PPV, so positive predictive value. So if we think about how the producer is using these models, if he gets an alert on his phone and he says, right, this animal is predicted to be lowly fertile, so that is going to get a beef straw. He wants to know for sure when the model says this is a low fertile animal, what percentage of the time is that model correct? So I appreciate that, yeah, the sensitivity fluctuates quite a bit, but when we're working with these models, you'd really do have to take a bit of a more holistic view on the metrics, but thinking about the producer, it's going to be PPV, I think, will be what he'll be really interested in. He wants to know what percentage of the time is this model correct when it says it's a lowly fertile cow.
So when we added data to develop this program, based on how many samples were there, do you add information to that to improve the sensitivity of the model system as well, or not?
So a bigger data set, is that what you mean?
Yes.
Yeah, well, so we 9,000 lactations across 25 herds is a relatively big data set. When I spoke about the issues we have with applying models that are very, very complex, there's two issues to that. The latter one I spoke about, which is they're more difficult to apply on farm because we're putting a higher and higher bar that the farmer has to meet. He has to have a rumination sensor. He has to have a milk and fat protein sensor, okay? But the other side of that problem is it's harder to generate data sets when you're looking for a huge amount of variables. So to give you an example, when we would have first had this data set, we would have been up in a region of 20,000 lactations. But when we had to cut that down because of missing variables and sensors had malfunctioned, then it comes down to 9,000. So yeah, if we had a larger data set for sure, we might get a better idea of those fluctuations in sensitivity and specificity might be lower, but that is one of the issues of trying to work with a model that has a huge amount of variables in it.
Thank you. Do we have any other questions? And if not, we'd like to thank Fergus for the fantastic. Okay. Our next speaker is Alejo Menchaca, excellent, from University of Kansas, is right? Yeah, Kansas State University, because the information doesn't say here. Thank you.
Hello, everyone. My name is Alyssa Leslie, and I am from Kansas State University. And today I will be presenting some research that I had the privilege to conduct during my master's at Kansas State. And that is the evaluation of a needle-free injection system utilizing cloprostenol, otherwise known as Estramate, produced by Merck Animal Health, for the purpose of luteolysis in lactating dairy cows. So for some background on the needle-free injection machine, it's one that utilizes compressed air to ultimately administer a drug either subcutaneously or intramuscularly. You can adjust this setting based on the PSI, or pounds per square inch. In this machine, if you look to the right, there's an image depicting a needle and syringe administering a drug, and on the far right, the needle-free injection machine administering the drug with pressure. So on the left, our needle and syringe ultimately makes a small hole administering the drug in the hypodermis, and then the needle-free injection machine makes a smaller hole and disperses the drug more evenly throughout the hypodermis of the skin. This needle-free injection machine comes in various sizes depending on the volume of the drug that you'll be injecting into the animal. The machine that we utilize specifically will be seen later in the presentation, but it's fairly small enough. It was small enough to fit in a vest pocket, which is pretty handy, and ultimately it's ideal if you use it in a rotary situation, so you can effectively administer drugs continuously within a group of animals. And it's pretty easy to use. It does require some employee training, but it took me all of 3 minutes to learn how to use the machine, so it's pretty doable to utilize in an operation. This machine ultimately mitigates those recurring costs of needles and syringes, which can add up pretty quick for a large dairy cattle operation, especially when you're trying to estrus synchronize these animals to achieve pregnancy in a timely manner. So with the use of this machine, you can ultimately mitigate those recurring costs of a needle and syringe. It also helps prevent needle stick injuries in our employees, which is a huge deal because these drugs that we're using in these animals can have pretty detrimental effects to our health. So if we're able to in any way mitigate those injuries, this is one way to do it. And this machine has also been shown, Reinbold and others showed that it has decreased disease, bloodborne transmission of specifically Anaplasma marginale. And so that's definitely an added benefit to this machine as well. And this machine has been used throughout swine operations for mass immunization because it helps prevent possible meat quality issues with needles being used in those swine as well. So for our study objective, we ultimately wanted to evaluate the effectiveness of a needle-free injection system provided to us by Pulse Needle-Free Systems from Lenexa, Kansas, for intramuscular delivery of cloprostenol or estramate in our lactating dairy cows for estrus synchronization. Our study hypothesis was that our two cloprostenol groups would show no difference between the different administration methods from a needle and syringe and the needle-free injection machine. And we also hypothesized that the needle-free injection machine might offer a lower stress injection method as well. So for our study criteria, we utilized Holstein dairy cows provided to us by the K-State Dairy Teaching and Research Unit located in Manhattan, Kansas. That herd consisted of multiparous and primiparous cattle. These cows were around 60 days in milk, and they were estrus synchronized ahead of time to achieve an active corpus luteum, which was deemed one that was greater than 13 millimeters in diameter and greater than 25% blood flow. And these measurements were taken with an IBEX ultrasound that had both measuring and Doppler capabilities. For our study design, we utilized 26 lactating Holstein dairy cows randomized into 3 different treatment groups. Our first treatment group was one that was our control, a total of 6 cows receiving 2 mL of saline administered intramuscularly in the neck according to beef quality assurance standards for that injection site specifically. And we did utilize the needle-free injection machine to administer that 2 mL of saline. Our second treatment group consisted of 10 cows that received 2 mL of cloprostenol intramuscularly again in the neck using the needle-free injection machine. And then our final treatment group consisted of 10 cows that received cloprostenol intramuscularly in the neck using a traditional needle and syringe technique. And then to the right of the screen is the machine that we utilized. It looks kind of big on the screen, but it's actually pretty small enough to fit in the pocket of a worker's vest. And then the blue gun is what you actually press to the skin of the animal, and then you pull the trigger, and it utilizes the compressed air to ultimately push the drug under the skin or into the muscle, depending on the PSI that you set the machine to. So this is just depicting the ultrasonography measurements that we took of these cattle. So we measured their corpus luteum diameter, via ultrasonography through rectal palpation. So on the left-hand side depicts the diameter being measured with a simple X dotted line using those capabilities on the ibex. And then on the right is the Doppler measuring the blood flow going to that CL. So this CL specifically is very active. So for our outcome measures in this study, we looked at several different parameters, with our first parameter being cortisol, and these cattle were catheterized for comfortability of these animals because we did pull blood pretty frequently throughout the first 2 hours following treatment. And then that data was computed using a radioactive immunoassay. And then we looked at progesterone, CL diameter, and CL blood flow. Progesterone was again pulled through the coccygeal vein instead of the jugular, and it was less intense of a sampling period. And that was also, we utilized a radioimmunoassay to analyze that data as well. And then for our CL diameter and blood flow, we utilized the ultrasonography ibex. So for our corpus luteum diameter, on the y-axis, we have our corpus luteum diameter being represented in millimeters, and on the x-axis, we have our time being represented in hours. And for the remainder of this presentation, our key will remain the same for the rest of the graphs. So our purple circles denote our needle-free cloprostenol group. The black squares denote our needle and syringe cloprostenol group, and then the gray triangles will be our control group or the needle-free saline group. So for our corpus luteum diameter, we ultimately found that there wasn't a significant difference between our two cloprostenol groups, the needle and syringe and the needle-free cloprostenol group. However, the needle-free saline group did show a significant difference between those two cloprostenol groups, which makes sense, denoting that our administration of cloprostenol groups in our two treatment groups effectively decreased the diameter of that corpus luteum following administration. So for our corpus luteum percent change in blood flow being represented on the y-axis, and then our time on the x-axis in hours, again, we have our purple circles being our needle-free cloprostenol group, our black squares being our needle and syringe cloprostenol group, and our gray triangles being our needle-free saline group. So again, there was no significant difference between our two cloprostenol groups. Both of them showed a decrease in that percent change of the blood flow going to that corpus luteum following treatment administration, whereas our needle-free saline group held a pretty steady percent change in that blood flow as time went on, again denoting that the cloprostenol administration did in fact work. So for our percent change in progesterone concentrations, we have that being represented on our y-axis. And then on the x-axis, we have our time being represented in hours, with the dotted line at 0 being our base for that percent change in progesterone concentrations. And for this graph specifically, we show that our control group or our saline group showed a positive percent change in those progesterone concentrations, whereas our two cloprostenol groups showed a negative percent change in those progesterone concentrations, again indicating that our administration of cloprostenol did not differ between our needle and syringe group and our needle-free group, allowing us to effectively cause luteolysis in that corpus luteum. So now moving to our cortisol concentrations being represented in nanograms per mil on our y-axis, and then on the x-axis we have our time being represented in minutes. This graph is a little chaotic just due to the frequency of the interval that this data was taken in. It began as 2-minute increments and then slowly increased as the 2 hours went on. But to kind of break it down, we ultimately showed that our black squares, or our needle and syringe cloprostenol group, did have a significant difference in those cortisol concentrations from our needle-free cloprostenol group specifically. So the asterisks denote that significance at those specific time points. So for our needle and syringe cloprostenol group, they did show higher cortisol concentrations than our needle-free cloprostenol group specifically. So in conclusion, we ultimately found that there was no evidence of a difference between our needle-free delivery of cloprostenol and our needle and syringe delivery of cloprostenol, ultimately denoting that corpus luteum regression was achieved in both of those groups, and it did not differ between the needle-free delivery and the needle and syringe delivery. We also found that cortisol concentrations were in fact lower in cows that received the needle-free cloprostenol treatment specifically than our needle and syringe cloprostenol treatment cows. And for some discussion, our needle-free system can ultimately be utilized in our production operations and could be a probable replacement for a traditional needle and syringe administration of cloprostenol specifically. This was a pilot study, so more research needs to be done, especially utilizing other prostaglandins and other reproductive management drugs. And I think it would also be pertinent to look closely at the cortisol concentrations in the future with another study to see how that might differ between the needle-free and needle and syringe group. The results were suggestive that the needle-free cloprostenol group may have had a lower stress experience than our needle and syringe group, but again, more research should be done before we ultimately come to that final conclusion. And overall, this needle-free injection machine can greatly decrease the risk of disease transmission in our animals as well as our employees. It can also help prevent needle stick injuries in our employees, which with the drugs that we are handling in these animals on a day-to-day basis is a huge, huge thing for our employees as well as ourselves. So for further research, this image to your right denotes a cow's neck being held in a stanchion or a chute or a head catch. Her head would be towards the right side of the screen and her body would be towards the left side of the screen, with the top of her neck at the top of the screen and then the bottom of her neck at the bottom. You can see her jugular catheter inserted there. And then you can also see on her where the injection was made using the needle-free injection machine. This was one cow that it happened to in our study out of the total of 26. And she did have this welt or raised nodule area after administration with the needle-free injection machine for about a day, and then it disappeared. So looking closely in the future at possible injection site effects from this needle-free injection machine would definitely be pertinent. And then it would also be ideal if we could compare the different luteolytic drugs with this machine as well to ensure that they're being adequately dispersed throughout the animal and achieving luteolysis, as well as looking at possibly using a GnRH analog with the machine as well, because this would also help mitigate even further costs of needles and syringes when estrus synchronizing these cattle. And with that, I'd like to acknowledge all of the people that helped me with this project, as well as Merck Animal Health for their support, Pulse Needle-Free Systems for the use of their machine, and the K-State Dairy Teaching and Research Unit for the use of their facilities and cattle. With that, I will take any questions.
Thank you, Lisa, for an interesting talk. Is there any questions for Alyssa? Yes, please. Come to the microphone in the middle.
Right. Thanks for the presentation. And I assume you measured cortisol in blood, right?
Yes.
And how did you collect the blood samples?
We collected the blood samples through the jugular catheter roughly every 2 minutes for the first 10 minutes, and then it increased to about 5-minute increments, and then 10, and then 20.
So catheter was on the animal all the time, right? If I'm not mistaken.
The animal was caught? Yes.
So you constantly get the blood for this time
Yes,
period?
yes.
All right. Thank
Yeah,
you.
thank you.
Okay, thank you. Any other question? Okay, maybe I ask one question. So what about the cost of this machine?
Yes. So the cost of this machine ranges depending on the size and machine that you choose. The model that we used specifically for this study was around $6,000 US. So it's definitely something that needs to be computed before diving into purchasing one of these machines because they can be pretty pricey. But over the course of several years, the machine could ultimately pay for itself when you don't have to continuously buy needles and syringes, as well as any possible employee needle stick injuries that could cause harm in your employees.
So certainly it's good for animal welfare.
Yes,
right?
yes.
Is there any questions before I ask the last question? Yes.
So, thanks for the presentation.
Yes.
I have one question. You were mentioning the possibility of using it in a rotary parlor, but
Yeah.
of course then the injection site should not be the neck. Okay.
Yes.
Have you managed to test this alternative opportunity or not?
We have not personally been able to test it on a rotary. There are a couple rotary dairies in the United States that are using this machine. I have not personally visited them to see how exactly they're able to manage it. I have been told that they have a platform that the employee sits on with the machine so they don't have to do any moving. They just stay in one place, and as the cows move by, they inject whatever drug they're administering. But our dairy doesn't have the numbers to warrant a rotary, so we weren't able to do that, but that's definitely something we'd like to look at.
Thanks. And one other comment. The machine is fit on the vest, the operator, and he
Yes.
goes along on the headlocks. Does that make any difficulty from a practical point of view?
Yes. So the biggest difficulty with the machine is that you have to have a connection to a compressed air source. So you do have to carry around a small tank. The tank that we had was about this big, so it was one that I could carry in my hand and had the machine in my pocket and then the gun in this hand, and I could just go around to each cow and administer it that way. But the biggest, I think, problem with this machine is the fact that you have to have a source of compressed air that you do have to keep on you at all times. But the machine that we had was small enough that it just fit in my pocket, and it really wasn't that heavy either. So, yeah.
Perfect. Thanks.
Yes, thank you.
Alyssa. I think we need to move on, and I would like to join me to applaud. So, our last speaker for this session is Benjamin Barber from the United Kingdom. So, please, Benjamin. So,
can I use the microphone? Or?
No, there is
There's one up
things
there.
there. And maybe a computer. This is moving a step forward.
Yeah.
This is backward. And this is the
Cool. And then there's this microphone on here.
Use this. Use this. Or you can use that one.
Is that? Hello? Good afternoon, everyone. Just to start with, I'd just like to thank the organising committee to obviously give me the opportunity to speak today. So my name's Ben Barber. I'm a vet with Synergy Farm Health, based in the southwest of England. And one of my main roles is actually being the veterinary advisor for a very large UK-based beef integration chain. And the question that I really want to ask today is how are calf IgG levels measured on the entry to beef rearing unit associated with their performance during that rearing period. And the aim of this talk really is to have a sort of a preliminary look at the results so far. But I think the things that I just want to point out at this stage is that the IgG levels we are measuring are in much older animals compared to normal. So I think a lot of us would be used to sort of calves being measured in like about a week of age. But the animals we were looking at were much older, so sort of between 2 and 8 weeks of age. And the test we were using was directly measuring IgG level. And this is sort of obviously a little bit different to some of the more common things we would use indirectly, so zinc sulfates and total proteins. But obviously being aware of the age we're measuring at, we felt that was quite relevant. So the study was entirely set at one place. So it was a large calf rearing unit in the southwest of England. The calves were on site for a 10-week rearing period. And after they went on to then another finishing unit. The unit is entirely housed indoors. It is straw-based. And the calves which were enrolled onto the study sort of were over quite a large time span, so they were entering anywhere from February 22 up to January 24 of this year. And on entry, we were measuring variables such as the breed, age, weight, sex, and dairy herd of origin, all of which we thought were probably going to be very important confounders in this. So during that 10-week rearing period, we recorded some of the outcomes we were interested in. So it would be treatments, mortalities, and we also had a wait at 6 and 10 weeks after being on farm. All treatments administered by farm staff, and this was done under a very strict treatment protocol, which was effectively an adapted University of California scoring system. I think this is probably just a good opportunity to say that all of the team which would have been administering treatments would have been blinded to the IgG results, so hopefully obviously we were just trying to reduce as much bias in this as possible. So this was the test we used. So it was a fully quantitative immunoassay in the form of a lateral flow device, the commercial name being Immunology, bovine IgG. And the method of taking the sample was something a little bit different. So we used a lancet, which you can see here, just to create a droplet of blood on top of the nose. And then that droplet of blood was picked up with a capillary tube. After collection, it was added to a buffer solution, and then the buffer solution was what was added to the lateral flow device seen here. After 10 minutes, we then placed the cube reader over the top, and that cube reader would give you a direct measure of that IgG level and give it to you basically in grams per litre. The test was performed pen-side by vets, all technicians under their supervision. And whilst it's not the sort of subject of this talk today, I thought it would just be worth clarifying that there is quite a lot of validation work which has been completed, measuring it against other direct forms of IgG, which are good correlation, but this is just in the process of being published at the moment. So this was the sample population. So in total, we enrolled 1,735 calves. There's a real big range of sort of breeds and sexes, and also a big range in age on entry, which was obviously also the age of taking the test itself. Age ranged anywhere from 14 days to 56, so 2 to 8 weeks. And actually going forward in a lot of the analysis, we also looked at age category. So we would divide them up and look at the 2 to 4, 4 to 6, and 6 to 8 week categories separately. And these were the IgG results. So this was all of the calves which were enrolled onto the study. IgG ranged anywhere from 0.6 up to 40. Just to clarify that the 40 is actually the maximum range for this test. So these were the animals who were reaching the maximum of the test. And just under 1/8 of the calves which were enrolled were sort of under 7.5 grams per litre. So one of the interesting associations we found was actually that with increasing age at entry, we did see a decrease in average IgG level. For us, this was a really important confounder to consider, because ultimately, we're very aware that age on entry is going to be really, really closely associated with some of the performance outcomes that we are interested in. So it was something that we really needed to be aware of when doing the analysis. And this is just a really brief overlook, really. So this was all the calves enrolled into the study, regardless of age. And no adjustments were done, so this is just the raw data. And this was just to give us a sort of a quick glance and overview of what we might be looking at. So what we did was we categorized calves into either above 7.5 grams per litre IgG or below 7.5 grams per litre IgG. And then we looked at the number of treatments which were administered for them. So obviously we have 0, 1, 2, 3, and then 4 or more treatments being administered to these animals. And just on visual sort of inspection, no stats or anything, you might start to think, well, actually, yeah, 4 or more treatments. There seems to be a slightly larger proportion of these animals, which were probably chronic animals in some form, and there was a slightly less proportion of those animals which received no treatment whatsoever. I think this is a good point just to say now, actually, that this particular farm, we would be doing no prophylactic antibiotics. So when we say 0, that's a genuine 0. So those animals would have gone through rearing with no antibiotics at that point. So we wanted to be more specific than that. So we started to look at specific questions. And the 2 questions really that we focused on were, what were the odds of calves being treated, yes or no? And what were the odds of a calf receiving multiple treatments, so more than one treatment? And these questions were explored with generalized linear models with binomial distribution. And those models were adjusted for weight, age, breed, and sex. And this is what we found. So the animals which were coming in at 2 to 4 weeks with IgG levels below 7.5 grams per liter, we were finding that there were indeed increased odds of being treated and increased odds of being treated multiple times. And for us, we felt these were quite clinically relevant numbers, but also we obviously had some quite satisfying p-values associated with that. The same question was then asked for the slightly older age group, the 4 to 6. And again, slightly increased odds of being treated and increased odds of treated multiple times. When we looked at the older age group, though, the 42 to 56, we couldn't see these associations anymore. So no associations with treatments in the older age category. So a lot of what we've been focusing on is obviously the 7.5 grams per liter, and some of this is probably based on other research out there. So a lot of the Belgian papers, so Pardon and Lowy, would have used some of these numbers, particularly because of the older ages which were coming in. But we also wanted to explore other different thresholds. So we were asking the same questions, so the odds ratio of being treated or been treated multiple times. And we asked the same questions, but with different thresholds. And I think we felt that we got some quite biologically plausible results, basically. So as threshold increased, whilst the odds ratio was still, we felt, relevant, it did decrease as the threshold increased, but still deemed quite significant. We did the same thing with the slightly older age group, so the 4 to 6 week group. Again, some associations still at the 10 grams, but probably losing those associations and that relevance once we get a bit higher. Really, my take home possibly from this slide is ultimately at different ages, we may wish to look at them in different ways and have different thresholds if we're deciding what animals are more or less at risk, basically. We also looked at daily live weight gain, so we explored that as a continuous variable, but as well as a categorical, so cause for concern. So the continuous was done via multivariable linear regression models. The categorical cause for concern, the way we categorized these animals was that if the 6-week weight gain was below half a kilo a day, they were classified as a cause for concern. And basically our experience with that is that these animals tended not to be able to reach spec towards the end of rearing. So basically they were animals which we already were starting to focus on. What we found was that the 2 to 4 week calves coming in, which had 7.5 grams per litre or less IgG, they did appear to have both an increased odds of being a cause for concern, but also there was a slight reduction, a 44 gram reduction in their 6 weeks weight gain. We didn't find any sort of further associations though with weight if we looked at different IgG thresholds or different age categories. So very specific to this threshold and this age category. As well as just looking at IgG at the individual level, we also want to look at sort of the dairy level from where we're sourcing. So these calves were being sourced from lots and lots of different dairies all over the UK. So straight away you can maybe start to see some of the risk factors in these sorts of systems. So of the 1,700 or so animals coming in, these were being sourced from 177 different dairy sources. What we did was then we filtered down to 51. These 51 being dairies which had supplied at least 10 or more calves to this study. And then we ranked them. So what we've got here is got the 51 dairies. Here we have the proportion of calves which is supplied with levels below 10. So these dairies were doing great. They didn't supply any calves below that 10 grams per litre threshold. Whereas over here, we were actually finding some dairies above half, above 50%, more than half of the animals they were supplying were below that 10 grams per litre threshold. After this ranking, we said, right, okay, let's do a new category, and then looking at the bottom quarter of these dairies, these were classed as lower quartile dairies. Subsequent to that, all the calves from these dairies were then also classed as lower quartile calves. So bearing that in mind, so with the understanding of lower quartile calves, we asked those similar questions. So calves from lower quartile dairies, remembering the age group, so we're only looking at 2 to 4 week calves in this one, we still found that actually there were increased odds of both being treated and of being treated multiple times. And this is regardless of their own individual IgG level. This is just based on the fact of what dairies they were coming from. What was really interesting, though, is actually when we asked the same question, but we filtered down and focused only on animals which were above 10 grams per litre, so in themselves, actually, we could say that they're quite satisfactory IgG levels. We are still finding these associations of high treatments and high multiple treatments. So ultimately, calves with satisfactory IgG levels in themselves, but from lower quartile dairies, still had a higher odds of being treated and of receiving multiple treatments compared to satisfactory calves from other dairies. So what are the practical implications? So if we take this message on board and say, yeah, we're aware that performance might be associated with IgG, what can we actually do with that information? So one thing we might want to consider is actually if we start to monitor this, or if we start to monitor IgG levels by dairy source, perhaps we could start to provide feedback. That's a really interesting sort of idea, but ultimately, whilst we do have a really good body of evidence behind colostrum protocols and IgGs within that first week, I think it's fair to say that we definitely need to do more work to understand how these IgG level changes over time. Ultimately, we're asking, what that dairy farmer happens to do on day 1 with colostrum. Is that still having those associations with these animals when they're 3, 4, 5, 6 weeks old? And ultimately, is the feedback that we're providing at that point, is that still going to be relevant? What's quite cool, though, is that we are now starting to do some of this research. So going forward, we are hopefully doing some sequential testing to see actually how these animals do as they progress. We can then start to think about interventions. So if we know these animals do have low IgG levels, they're potentially at higher risk, what could we do with them? So this might entail separate penning, potentially, and actually once they are separately penned, perhaps we want to give them better stocking densities, increase feed programs, or possibly reduce those treatment thresholds because we know they're potentially at a higher risk. I think this all feeds into also this approach of a risk-based approach. And at the moment, we are doing further work at machine learning algorithms. The idea being that these algorithms sort of give us an idea of calves which are higher or lower risk, but not just based on IgG, just based on all the variables that we're aware which have a factor. So this could be age, weight on entry, breed, sex, dairy, travel time, weather, all these things actually that we have access to already, but which could be feeding into this idea of what is a high or low risk calf. So to summarize, we felt there was very strong evidence that calves between 2 to 6 weeks with a lower IgG level on entry did have a higher odds of being treated and of being treated multiple times. There was some evidence that the 2 to 4 week calves had a reduced 6-week weight gain when arriving with IgG levels below that 7.5 gram threshold. There was some evidence as well that the 2 to 4 week calves from lower quartile dairies were at higher odds of being treated and of receiving multiple treatments, and this was true regardless of their own individual IgG level. And we also felt there is a potential for some form of risk-based approach based on these IgG levels if we're specifically focusing on that sort of 2 to 6 week age category. Limitations, I think we need to appreciate that this is one farm, and it would be really interesting to explore these associations on other rearing units to see what sort of associations we find. And then also, it might be nice to consider more objective parameters, so not just treatment, but actually potentially lung scanning would be a really nice thought going forward. Just to finish, I'd just like to acknowledge some people who obviously helped to get me here, so particularly Synergy Farm Health with both Alistair and Rachel Hayton, who supported me through this, Soma Biosciences, so Joe Dunbar, who helped develop the test. We've got the Buiatrics group, who supplied the Buiatrics development farm where this study was conducted. Biomeda UK, who kindly sponsored my attendance today. Chris Hudson from the University of Nottingham, who helped advise on the slides and the statistical analyses, as well as Innovate UK, who's helping fund some of this exploration into this IgG work. Brilliant. Thank you very much.
Okay, we have time for a couple of questions. Any questions from the audience? Yes, please. Thank you.
I have a.
Yes.
Am I on turn? Okay. Thank you for the good presentation. I have a question. I didn't catch it before, but did you check the level of dehydration in the calves when you do the sampling? Because we know that dehydration status can have an influence on IgG levels.
No, I'll be honest, we didn't check hydration status on entry. I think from our point of view, this was probably much more of a field study trial, and ultimately I think going forward it's probably something we wouldn't be doing going forward as part of a normal protocol. But I think I appreciate what you're saying. You know, that would obviously potentially have a bearing on concentrations, but no, not in this study. Okay.
Great, thank you. Any other question? Okay, I just ask one question myself. So the route of basically supplementing the IgG to the calf, is it through the diet or you apply other methods?
Say that again, sorry.
IgG that you applied or supplied to the calves. Okay, after you did the test, you detected the level and supplemented with some IgG.
No, so we didn't do any supplementation as such, and basically this was a case of just looking at IgG level and obviously following these animals through to see what was going on. I mean, if we're talking about interventions, I'm not sure if that would be one to consider, but I think, yeah, we'd want to consider what interventions could be possible, and that comes on to the idea of stocking density, feeding, treatment thresholds. Yeah.
Okay. Could this test be used for measuring IgG in the colostrum or in milk as well?
No, so this is really just for calves. So it's all potentially all ages, but it would be the blood droplet which we're focusing on, and then IgG levels in the bloodstream, really. Yeah.
In terms of sensitivity, also tested.
So the sensitivity and specificity, I can't say now, but I think that's some of the work which is underway, basically, with regards to validation work. Yeah.
Thank you. Any questions? Okay. If not, I'd like to thank Benjamin for
Thank you.
So, yeah, I would like to thank all the speakers from this session. Another round of applause for all the speakers, please.